So welcome everyone, and we are going to understand AI ecosystem fundamentals from absolute beginning. Before we get started, let me introduce myself. My name is Yogesh Raheja. I'm having almost 18 years of experience. I'm core into DevOps, cloud automation, containerization, and recently, couple of years back, I have started this fantastic journey with ML, AI, generative AI as well. So I have authored a couple of books which have been published globally by John and Wiley, Pact and Orange AVA publications. Even there are a lot of Udemy courses which I have created. So you are going to get access to AI ecosystem, mastering prompt engineering and generative AI essentials. So once this session will be over, you all are going to have the access to these 3 courses as well. And you will going to get lots of details in it. So let's get started. So now this entire conference is divided into 2 parts, day 1 and day 2, or primarily you can say part 1 and part 2. So part 1, we are going to understand the fundamentals of AI. So this one. So we are going to get started with AI evolution, how AI came, some real-time examples, and especially understanding this AI ecosystem. Now, AI was there in the beginning as well, 20, 30, 40, and even 50 years back. But why it was not very famous at that point in time? And there is a reason to it. And we are going to understand that reason as well. And then we are going to have some hands-on demo on AI. So we will see the image detections, label detections, and there are many other. And then we will go deep into ML, the type of learning, the algorithms, use cases, and then I'm going to show you one of the demos of machine learning as well. And even I'm going to show or demonstrate something which you can even do on your laptops as well. And then we'll understand why ML is insufficient to handle the complex data. And that is why the ANN or artificial neural networks and deep learning came into picture. So this is all we are going to understand today. Once this is clear, tomorrow we are going to have the entire things on generative AI. So why Gen AI? Why Gen AI came? Why the DL was insufficient to do the things or ML was insufficient to do the things? What is the differences between generative AI and traditional machine learning? And then the transformer architecture, because this is the core for your generative AI. You are prompting something to ChatGPT and ChatGPT is giving something, but under the hood, there is some architecture which is doing entire stuff. And that is actually transformer architecture. And then there are core algorithms of Gen AI, GANs, VAs, FMs, LLMs, RAG. These are some of the generic terms. You need not to remember these terms. You will automatically going to understand them tomorrow. Then there are many tool sets. Now people think ChatGPT is Gen AI, but trust me, it's just 1% of Gen AI. 99% of Gen AI is still unexplored. And there are many players in the industry who are helping us to do that. And there are many tools indeed. And then finally, we will understand prompt engineering. Very crucial. Example, google.com. Now Google is always there. But the people who know how to search data from Google are the one who actually extract the good outputs. Likewise, ChatGPT is there for everyone. Even Copilot is there, Gemini is there. So these tools are there, text-to-text tools are there. But if you don't know how to put your prompt, you are not going to get the actual outputs, the relevant outputs. So prompt engineering is very important to understand if you want to get the desired results. So we are going to have almost 8 to 10 examples, hands-on examples with various tools, including ChatGPT, Datasquirrel, Ask Your PDF, and many other, so that you can actually relate them to your use cases. And this is for everyone, for HR, for L&D, for technical people, for managers, right? Because these all tools will going to save a lot of time for us. And then finally, as you know, when cloud came, people were thinking cloud is not secure. But when you talk about today, almost 50% of the industry is using cloud, and cloud is still the same. Likewise, when we talk about AI, there are certain precautions which we need to take because the entire compliance is still building. Data privacy, fake content, and so on and so forth. So there are certain limitations, but the compliances are being built. So again, it's an endless process. But yes, we will understand what are the risks and how we can mitigate them and what are the ethical considerations which we need to take. So without further delay, let's get started with our part 1. So the first question is, what is AI? Now, when we talk about AI is artificial intelligence. Now, let me come back and let us understand it in a simple layman language. Now, AI, artificial intelligence. Now, when you talk about intelligence, intelligence is always related to humans. Now, what we are doing, we are incorporating this intelligence artificially to machines. And that's the reason we say artificial intelligence. We are making machines to think like human. Now, when I say to think like human, that doesn't mean they will become human. No, it is impossible. But what we want them to have at least some intelligence. But for that intelligence, they are not that intelligent that they grab everything themselves. No. For that, we need to have a clear data, good data. If anyone is saying data or if anyone is saying data sets, it's the same thing in AI. You need a clean data. You give this data to machines and you ask machines to learn from that data. They cannot learn automatically. We give data, they learn. And then they take decisions intelligently. And basis on that intelligent decisions, they give us the relevant predictions or outputs. In simple layman language, this is artificial intelligence. Very simple. Making or mimicking machines or computers to think like humans so that they can take the decisions of their own is called artificial intelligence. But to achieve this, there is a huge ecosystem, huge ecosystem. So if I come back here, right, this is what we have just understood. Development of computer systems as an attempt to replicate human intelligence. But always remember, machines are not going to become human. We need to train them, and for that we need data, and data is always limited, so they are never going to replace humans. Simple. Now question comes, Yogesh, this is okay, but can you please tell us some of the examples which we use day to day? Absolutely, yes. The first one is retail websites. Now, instead of actually telling it, let us do it. Let me go to amazon.com or amazon.in. Let me come here to a search bar and let us search for biographies. Click. Now these are biography books. See here, many books are there. And see here, there is Ratan Tata. Let's say I click on Ratan Tata. And again, let's say I invest 30 seconds or 1 minute to it. There are many other, things here. If you see here, many other books here. Let's say I click on one more for Ratan Tata. And I just come here, I read some description, and I invest 2, 3, 4, 5 minutes here, and all done. Now, if you see here what I'm doing, I am searching something which is a book. And that book is related to Ratan Tata. Now, if you go back to your main website, and if you scroll down, it will show you the items which we have recently viewed. And even if you come down, see here, keep shopping for. What it does, if I open it up, it will actually going to show you, it will start showing me the searches which I have done. See here, Ratan Tata, the new book came here. Likewise, if I again go back and scroll down further, see here, the ideas inspired by your shopping history. See this, Ratan Tata, Ratan Tata, Ratan Tata, Ratan Tata, Ratan Tata. Now, what is this? This is one of the best examples of artificial intelligence. Basis on my clicks, basis on what I am searching, basis on my internet browsing history, the Amazon is itself learning everything. Or Amazon.in, the retail website is learning automatically. And it will start showing me the details which I have recently searched for. And this is not the only case. Now here I'm not logged in. If I would have been logged in here, my mobile phone will also start showing the similar details to me or similar searches or similar things to me. What is this? This is machine learning. Even I'll give you one more example. Let's say we search for a TV. Now, if you come down, or let us check anyone, let's say I click on this LG one. and I scroll down. If you see this thing, discounts, it's 49,990 INR and it's showing us 32,990. Now, this is also done intelligently using artificial intelligence. Basis on our area, basis on where we are based out at, what brands are more popular there, what will happen is you will start getting searches like that. See here. And if you see this, right, if you see discounts here sometimes, right, you see discounts here. So when you see discounts here, like this, say 500, say 500, many times you will see a cross and you will see 10% discount. Instead of 20,000, you have to pay 18,000. Those all things are actually being taken care by AI ecosystem. You cannot do that thing using manual approaches. It's impossible. So any retail website, when you talk about today, they all are intelligently driven. So they all are using artificial intelligence under the hood. Another example, cab service providers. Let's take an example of Uber. Let's say I am going to my office on hybrid mode and there is too much traffic, so I prefer cabs. So I'm going from my home to my office on Monday and Wednesday. Let's assume. Now what happens? 1 week, the pattern will be learned. Pattern will be understood by your Uber. And next Sunday, in evening or afternoon or even at night, you are going to get one message that for local travel, use this coupon code and avail 10% discount. This is exclusively for you. What is that? How can they know that I am going to travel? What they do is they understood or understand the things from the patterns you have followed earlier. So Monday and Wednesday, they will give you a couple of coupons for a couple of weeks, not forever, couple of weeks. And then when that pattern is completely understood, they know you will come and then those coupons will be decreased. But if you are new, you will see the Uber is learning from that pattern or even Ola is learning from that pattern and they start giving you some perks. This is intelligently handled by the AI models which they have deployed in their applications. Right? Now, the next one, language translations, NLPs. Very good example. Now let's consider that you are on a travel and you are going to a country where they don't speak English and they don't speak the native languages like Tamil or Hindi. Now what happens? You are going to a restaurant, you are hungry. Now the menu is completely in a different language. What you will do? You are stuck. This is where AI applications will come into a picture. You have Google Lens. Use that. Scan it and it will translate that language to whatever language you want. So it will going to be your best friend. So NLPs, natural language processing, is actually changing the entire world. So this is very, very good and very, very important for us. Even you can check the same thing in your mobile phones. Just open a note and say, hello, how are you? And you will see it will start writing things for us. What is that? AI. Let me show you. I think I can be able to show you that. Hey, can you please open a note and write, hello, how are you?
Okay, I've created your note. It's called Hello, how are you?
See this. Hello, how are you? What is this? I'm speaking something and I'm asking my laptop, my machine to write it in a notes. See this. Hello, how are you? This is NLP. This is artificial intelligence. Great, right, everyone? And likewise, there are many examples, many examples. So I'm taking these all simple examples so that you can understand it, because this is something which we see every day. Retail websites, I'm pretty much sure every one of us use Amazon or Flipkart or Snapdeal, right? Or Myntra. So they are all artificial. They are actually having artificial intelligence mechanisms or algorithms underneath them. We book cabs via Uber or other service providers. Definitely. We get coupons. They understand our patterns. AI. Language translations. Wow, wonderful. You can go to any place. You can have the things written in a different language, you can translate everything to English or Hindi or Tamil, whatever language you want. Ask the AI assistants to write the entire things for us, like I did for notes. They are all artificial intelligence examples in real world, right? Next. Now, history. People think AI is just, 5, 7, 8, 10, 15 years old, but it's not the case. As far as my knowledge is concerned, thou, when you read on Google, you will say it came in 1920. But I don't know what are the evidence there. So I'm just showing you the evidence which I know. But again, artificial intelligence is even older than 1943. So in 1943, the first time AI came into a picture, because that was the time when evolution of neurons came, the intelligent network. Basis on that, in 1966, it took huge time. The first chatbot was created, which was called Eliza, like we have ChatGPT today. And then the first human robot was created. First human robot, 1972. And then XCon, expert configurer. The first supply chain automated software was created. Orders are coming, orders are getting created, orders are getting dispatched. So you have, and they are just getting fit on whatever racks you want to set them. So that was the first expert system which was configured in 1980. And after that, Deep Blue came. Now this is the time when people actually know that AI was there. Now the first robot was created, or first intelligent system was created. Now IBM Deep Blue is very famous. If you search for it, you will see this was the system who have defeated the world champion in chess. So machines have defeated the world champion for the first time. Now, if you go and check this history, 1996, the first match was happened, or first competition was happened, and AI was lost, and the chess champion was the winner. Then they have remodified multiple things, and in 1997, again the competition happened, and IBM Deep Blue, the machines won. So the winner was IBM Deep Blue. That's the reason it's very famous. If you I would highly suggest you to go and check the history of it. And then again, IBM Watson. Now Watson, people start talking about Watson in 2010, 2011. Now this was actually NLP. The first biggest NLP system was created, which is IBM Watson. So it was used for text to text transition, speech to text transition, and so on and so forth. And then finally, lots of tools came. Google Now, right? The older one. Now you want to check the restaurants nearby you, Google Now. And then again, in 2015 onwards, the music industry have been revolutionized with AI softwares or AI devices or products. Amazon Echo. Hey Alexa, can you please play music for me? Hey Alexa, can you please play this music to me? Hey Alexa, can you please switch on the lights? Switch off the lights. Can you please read me the top 10 news for today? So those all Amazon Echo. And I'm sure Google Echo, Amazon Echo, most of you are familiar of. They all are AI ecosystems or AI products. Then we have Google Assistant, similar to it, but again, little more advanced. Example, you say something, a text is being created and sent to someone, right? You want your entire calendar to be managed. You want text to text transactions to happen, all Google Assistant. And then finally, 2022, November 2022, rather, I should say, ChatGPT. Now you ask anyone, okay, can you please write an email for me? Absolutely, I can do that. Can you write a good email for me? Definitely, I can. How? ChatGPT. And now when you talk about 2024, trust me, there are tons of softwares available. Some are even better than ChatGPT. So this is how the entire evolution of AI have happened. From 1943, again, it's way before that, but the evidences are there from 1943 till 2024, till date. Many new things have been happened and lots of research is going on. Now question comes, when AI was there in 1943, then why it was taking 20, 25 years to build something and then move forward and then build something? And why the evolution is so fast today? There is a reason to it. Now let's understand that reason. It's easy to say that we have AI, we can build applications, but it need a lot of things under the hood. Let us understand those under the hood things, right? But before jumping into that, some business benefits for quick reference. So enhanced efficiency and productivity. Now, as I always say, now when cloud came, when automation came, people were thinking humans will be replaced. No, that's not true. Because humans are the one who are creating these systems. Likewise with AI, don't have any fear in your mind that something will happen to us. No, nothing will happen. But we have to be ethical. This is something which we need to consider of. We have to make AI your friend so that we can actually save time and increase our efficiency. Example, let's say you are developing a product. Product is developed, the basic structure is clear, the basic documentation is clear. Now you want to enhance that or detailed out that documentation. You can leverage AI ecosystem for that. It will save time for you. Instead of investing 1 month or 15 days in creating big product descriptions and specifications, you can leverage AI ecosystem for that. It will save those 15 days or 1 month to, let's say, 1 or 2 days. And then you can focus on the other product and the other product. So this is how we can make AI as our friend. Next is data-driven decisions. Example, um, let's say there are 4 products and out of for one company, and they want to see how the growth is going on, and they want to predict on which product should we put our more focus on in future. Now with humans, you can definitely do that, but it needs a lot of time. And you might be missing some of the factors. And that is the reason what we do is we actually use AI or machine learning specifically in such cases to make predictions. Okay, we have 4 products. Basis on 4 products, we have this entire data of last 10 years since the product have been developed for the first time. So can you please understand the patterns and suggest us for next 2 years how things will go on, the future predictions? So it will tell, okay, this product likely to go here, this product likely to go here, likely to go here and there. And basis on that, the organization can take decisions. Okay, let's put 50% of our efforts to this product because it is having a good future, right? And make most out of it. Let's put 25% efforts here, 10% here, and let's say 15 or 5% here, so that you can actually earn profit out of the products which are in demand. So that is where your artificial intelligence can help you. Improved customer experience. Example, if again, I'll specifically talk about India. Now the problem is the product when you purchase, after service is horrible. I don't want to take the name of the companies because we are going to share this publicly with you. But almost 50% of the organizations, product companies, when you take a product, their after service is horrible. Yes or no? Just raise your hands. You can consider telecom industry, you can consider TV industry, right? Electronics industry, and so on and so forth. Now, when you actually want to talk to their customer care also, it used to take almost 1 hour to reach to a right person. Now, this is what you can improve using artificial intelligence. What you can do is you can create the extraordinary ecosystem of chatbot, of speech, right? So that you can actually get relevant answers in lesser time, which will actually improve and increase the customer experience towards those products and companies. Many companies are doing it, but still a lot of improvement is required because again, machines are still learning. And until and unless things will not learn, definitely the expected response and result will not be there. But many companies have adapted that. They are training their ecosystem on their product so that you can actually get the answers quickly. This is one of the brightest fields in AI. Cost reduction. Although it is not evident to say cost reduction, but there are two things into cost. One is the capital expense and one is the operational expense. Capital expense with AI is huge. It's not easy. Developing a model, deploying a model, underlying hardware, it is too expensive. It's not like our laptops where CPU works. You will always going to have GPUs and TPUs, which are not as cost effective as we think. But once the things are done, then definitely there will be a shrinkage in the cost. So your operational expenses will be less. And that's the reason we highlighted that there will be a cost reduction, but after a certain time, right? Next is innovation and competitive advantages. Now, as you know, you go to any product today, they all say AI enabled. Either they are enabled or they are not enabled, but you will see this term, we are AI enabled. We are using AI technology under the hood, especially in electronics industry. You go, you will see this television, this washing machine, this AC, we are AI enabled. Now, because AI is such a big term, it's always good to use that in your products to actually increase your sales. And hence, if you innovate in such technologies for your products, that definitely there will be competitive advantages. So your competition, 50% filtration will done, and then rest of the players, your product will definitely outshine if it have those features. So enabling AI in your product will always going to be a great value add. Next is risk management. Now, risk and fraud detection is something which happened a lot, especially in financial domains, right? So the fake transitions or transactions. Now, when you talk about false transactions, definitely AI will going to help us. Definitely, because it will actually understand the pattern from where the things are coming, how they have crafted their emails or their texts. Basis on that, it will automatically detect either it's a genuine or it's a fake, and then it will block the things accordingly. So in finance, most of the organizations are working in order to create a fraud detection system for their transactions. A very boomed domain in financial industry today. Now, the thing which we need to understand, AI ecosystem. This entire AI ecosystem is actually divided into multiple layers. Layer 1, layer 2, layer 3, and layer 4. Now, before we jump into it, let me explain these layers to you. And this is the answer to a question, why AI took so much time. Now, let me come here. Now, we all people are aware of CPUs, right? Even when I go to my college days or my school days, having a Pentium 4, it was a dream actually. Pentium 4 processor. Having 128 MB of RAM was actually a dream. Forget about 256, 512 or 1 GB. I'm just talking about early 2000. So let's say 2000 to 2007. Pentium 4, Pentium 3. So these all were the processors. Now, I'll give you one simple example. I'm sure if you all belongs to my age, my group, we all used to play video games, and there was a game called Need for Speed. Need for Speed, Need for Speed 2. I'll give you a true example from my own experience. On my desktop, laptop was just a dream, impossible for us at that point in time. On my desktop, when I installed Need for Speed 2, my laptop was like this. Sometimes the clicks are working, sometimes the clicks are not working, and then reboot. Because computing power was almost negligible. Computing power. Now think about it. When to run a simple video game on a desktop or a laptop was this much slow, how can you run the big algorithms to do the predictions or do the decisions for us? Impossible, almost impossible, because computing power was almost negligible. Even in data centers also, when you talk about 2000, this time belongs to something called Unix ecosystem. And in Unix ecosystem, there was Solaris, there was AIX, there was HPUX, and there was mainframes as well. But mainframes was altogether a different technology, again from IBM. But the computing power, they all were having CPUs, only CPUs. They were meant to have only one application at a time. Forget about having tons of data and doing a processing on top of it. Impossible. That was one of the reasons it took so much time from 1943 till date to actually do the innovation, because we were not having the underlying infrastructure with us. And before, if we are lacking underlying infrastructure, definitely it will going to be too much difficult for us to do the things. Right? Now, this is where innovation came. Let me. Now, this is where innovation came. The first layer, the first and the most difficult one to get is hardware. If you have seen, there is one company which is in a limelight since last 1 year, and the name of that company is Nvidia. Think about it. The company which was Intel, right? The masters in hardware. But a small company like Nvidia, they just in 1 year everything got changed. Why? Because of this hardware. Now there are only two major players. One is Nvidia and one is Intel. Major stakeholding is with Nvidia. Now these are the companies who are developing a hardware, the processors, and those processors are either GPUs or TPUs for graphics. And if you see here, this is for your processing tons of data. So you have GPUs and TPUs. Unless and until this was not there, right? The computing power was not there with us. And hence the innovation was very less. Because you need to invest huge money and you don't know either that product or that invention will going to be successful or not. But now GPUs and TPUs, you have processing power with you. Hardware is there with us now. Now on top of this hardware, what happens? Now companies have created their platforms. And to create the algorithms, models, you need to understand the programming languages also. Now, when you talk about artificial intelligence, these platforms plays a pivotal role because not every organization or every person can create their own platforms. Again, impossible. Having your own data center is always going to be impossible because we are just going to do it for testing. And just to do a testing, purchasing the entire data center will always going to be, not a logical justification. Now, this is where the most of the cloud providers will come into a picture because they sell platform as a service. They sell data center as a service in simple layman language, right? So whatever offerings they have in their platform, they sell that. Now, this is where your AWS, Azure, and GCP will come into a picture. So they have created a platform. That platform under the hood is using this hardware. You need not to purchase a hardware. You just need to go to these platforms, choose whatever service you want to choose, right? And do whatever you want to do. Create your own application and then sell it off. In order to develop things, again, there are three primary languages which are very popular when we talk about artificial intelligence. The first and foremost is Python. Just for your understanding and knowledge, when we talk about Python, now there are two things in the industry. One is called cloud ready and one is called cloud native. When you talk about cloud ready, it means we are talking about cloud ecosystem. 2010, many companies have started this journey. And I know Genesis is also having their own cloud. So when you talk about the journey of creating cloud, the entire cloud, you talk about public cloud, you talk about private cloud, including AWS, Azure, GCP, DigitalOcean, Rackspace, Red Hat private cloud, OpenStack, Mirantis cloud, whatever cloud you talk about, they all are developed. They all are written in Python. So if you run anything and you want to make compatibility of that product with cloud, Python is the best language to go with. Similarly, from 2015 onwards, Now the race started in 2014, June 2014, but from 2015 onwards, again a new thing came in the industry. And again, most of the organizations are using it or plan to use it. That is called cloud native ecosystem. So you talk about Docker, Kubernetes, OpenShift, Rancher, CNP platforms, and so on and so forth. They all are cloud native applications, including Prometheus also, including Calico, Cilium, Weave, Flannel, all this entire cloud native ecosystem. This entire cloud native ecosystem, the containerized ecosystem, they uses Golang, Google language under the hood. So if you talk about artificial intelligence, you will see the Python is the best language to go with. And then you have R language. And then even traditional C++. Many companies are actually still relying upon C++ and developing their entire AI ecosystem with it. Too much robust, we must say. Right? So we have hardware, we have platforms, and we know which languages to use. Then what we do is we start developing our models. Layer 3, model development. We say Chat GPT, we say Gemini, we say Meta AI, right? Which is actually Llama. So when you talk about all these things, right? So what are they? Those are applications. Example, Chat GPT. Hello, how are you? Can you tell me about Yogesh Raheja? Enter. And it will give me something. Now that something is being produced by this model. This model. Now, when you talk about GPT for Chat GPT, till 3 it was GPT-3. You have Delhi. You have Llama. So when you hear these terms, quite often as an end user, we don't hear that. But if you hear these terms, GPT-3, Delhi, Llama, and there are many other, they are the algorithms. They are the models on which your data is trained. And that trained data is giving us the outputs. So this is model development. Most of the organizations, what they do, they use the already existing models and they fine tune it basis on their products or basis on their expectations which they want from their ecosystem. So this is for all those companies who are building the models. And the next one, the final one, is the applications. This is where people like us, right, we are interested in at present point in time. Applications. Now you talk about ChatGPT. You talk about Gemini. You talk about Copilot or any other. There are many applications available. Now, these are the applications which we as a user will going to use. These applications we will use. These applications are using defined models. Those models have been trained or built on the platforms which is actually running on hardware like this. Why AI was slow? Because of this particular reason, this one. Unavailability of the hardware. Now hardware is available. Now it's a big booming domain. Many countries are working on it. Think of it, if in India we have one hardware developing company who can produce GPUs and TPUs, the life of India will be altogether going to be different. Altogether will going to be different because it will going to be a big revolution in the industry for India. At present point in time, there are only two players, NVIDIA and Intel. So this is how the entire ecosystem have been arranged. Let me come back and show you. So let's see, hardware, GPUs and TPUs. Likewise, programming languages and platforms. You have Python, R, C++, AWS, GCP, Azure as a platform. And if you see this TensorFlow is actually a bridge between a model and the platforms. Right? Your entire google.com is using TensorFlow. So TensorFlow have been given to us by Google only. the open source learning or machine learning ecosystem. Next is the models. Now, you can have your own models or you can use the industry standard models. There are many. But just for your reference, because we use ChatGPT a lot, so GPT is actually having its own model called GPT-3. Now, because GPT 3.5 is gone, 3.x is gone, now they have the free one is GPT-4 Omni, which is 4.0, and the paid one is 4. Right? And then finally, on top of it, we have applications. So you talk about any application which we use as a layman user. You go to Google, search for AI applications, and you will see tons of application to create presentation, application to read PDF, application to do some analytics, application to do image to text or text to image transitions, or create a video, create a YouTube video, shorts, create the entire courses, and so on and so forth. They all are applications, all applications. But under the hood, now again, just to let you know one more thing, I come across one question many a times. Let me tell you that question. So people say that there is an application. That application is just giving me to create 3 images for free. And after that, if in a day, and after that, if I want, let's say I want 20, 30, 40 images, in a day, they are asking me to pay. Why? Now the why is this is just a promotional activity. Because under the hood, in order to create even a single image, those all layers, layer 4, layer 3, layer 2, layer 1. This will be followed. And this application company have to pay for the platform, for the hardware as well. So if they give everything free, they will be completely bankrupted for sure. And that is the reason what they do. They just give you a glimpse of that. And after that, if that tool is something which you can use in your organization, then probably you can take a paid version of that. Because these companies also have to pay money to the hardware vendor, to the platform vendor, and so on and so forth. So in majority of the AI platforms, you will see till certain amount things are free, but after that the things are mostly paid. So till the free part, if it is completing your work, definitely you can use it. But if you think you wanted to go beyond it, then definitely you have to go with the paid version. Because these companies are also paying for the infrastructure, for the platform to the other vendors as well. Or if they are maintaining their own data center, that's the capital expense for them. Right? So majority of the time you will see this. Something is free, but other things are paid. Next. Now, this is again the next question which comes. Is AI equivalent to human intelligence? The answer is absolutely no. No one can replace humans. That is for sure. Definitely, there might be some impact, right? Like people are saying, some impact, but not the entire impact that the humans will be changed. I'll give you one example. Now we are talking about goods of AI, but recently, a week back, I was reading one article wherein it have been published that in one of the retail centers of Amazon in US, the humans are replaced by robots. So whatever work humans used to do, right, putting things in the shelves or taking material from one place to another place, and so on and so forth, those entire ecosystem is replaced by robots. Now that is an impact, yes. So that's the reason we say impact might be there, and definitely it will be there, but it will not going to replace humans for sure. Human intelligence cannot be taken by machines anytime or any day. No. But little impact in manufacturing industry, retail industry, it will be there. Yes, definitely it will be there. Right? So use cases. We'll take the questions, everyone. So now use cases. First is weather forecast. Now, one of the best examples of artificial intelligence are these use cases. So the first one is weather forecast. Now, if you all open your phone and just go to your weather app, you will see the predictions for next 10 or 15 days. Now, how those predictions are coming? Those predictions are all coming from your artificial intelligence ecosystem. Even if you go to Google, let's say I come here and I say temperature for, let's say, Mumbai for next 10 days. See this. Sorry. See here. 2nd September, 3rd September, 4th, 5th, 6th, 7th, 8th, 9th till 16th. So it is for next 15 days almost. See here. How this data is coming? Who is doing it? Are they humans? The answer is no. This is all happening via AI ecosystem. And again, specific to India, 15 years back, approximately 15 years back, our weather department was not so accurate. I am sure you all will agree to it. They used to say rain and it was all sunny that day. They used to say sunny and it was raining all over that day. Correct, everyone? 15 years back, when we were having DD national TV and we used to see the weather report, right? It will rain today in Chennai, it will rain today in Bangalore, but it never used to rain that day. The accuracy was not very good. 15 years back, India weather department. Correct, everyone? Just raise your hands if you agree to my words. Perfect. But when you compare the same thing today, right, 2024, you will see that accuracy has been increased a lot. If you see the predictions in the weather applications, it might rain. They will tell you even 50% rain chances are there. 70% rain chances are there. It will be sunny all over today. The temperature will go maximum 36 degree and minimum will going to be, let's say, 27. So such kind of predictions are approximately 95% accurate today. How is it possible? This all became possible because of the traditional data and the intelligent machine learning ecosystem. Right? So they do lots of permutations and combination, understand lots of features and parameters, and finally present us with the right or approximate right predictions. This is called predictions. Machine learning will always going to do the predictions. Machines will always going to predict, right? And that prediction should be accurate. It's not that it will going to be 100% that, but it should be likely to be 100%. This is one example, weather forecast. Another example, stock market. Again, very simple example. We have agents today. We go to agents, we tell them, okay, this is a money, can you please invest it for me in good stocks? What they do? They apply their brain, yes, definitely, but they use ML ecosystem also now. Because ML ecosystem will have the data, the traditional data, and basis on that, it will do lots of permutation combinations on various parameters and features and come up with the top 10 or 15 stocks to purchase, which are likely to have a very good value in future. And basis on that, they invest your money. Super. So wherever you see about forecast applications, forecasting applications, right? Weather forecast. Again, one more example. Product recommendations or products. Which product will likely example? There are tons of, let's say, tons of laptops or let's say phones. Now you want to categorize the different, categorize them in a different group, and then you want to target the sales to that group. Right? So this all prediction, sales forecast, you can take care using ML algorithms. Many companies are doing it. It's called recommendation systems. Next is image recognition. Very good example. Now, when you talk about image recognition, many use cases are there, but let's start with a simple one. You are presenting 100 images to a machine and asking the machine to separate, let's say, a girl with A, B, C, D, E, F features. And what machine will do is machine will actually search in that and it will going to give you the final desired output, which matches the features you have incorporated. First example, right? Even in fraud detection, it can be used. Identify a person who is behaving little different than the normal one in any mall, let's say any shopping mall. You can use image recognition in that. Second example, a good one. I'll give you a case study actually because it's very useful. Now, let's talk about any retail outlet. Let's say Zudio, simple. Now, did you people have noticed that whenever you go to any retail outlet, you will always see their most selling products will be at first place and they will target a specific audience. Now, I'll give you a real example. When you go to any retail outlet, you will always see there will be the first floor, especially the entrance. You will see the entire floor is for women's or girls because the prediction have happened at the back end. Now, using image recognition, right? The research have been done that who invest or spend more time to which products. So they will see, okay, girls, they invest 50 minutes in clothing, let's say 20 minutes in jewelry, and let's say 1 hour in their shoes department, and so on and so forth. So what they will do is they will arrange the things likewise. And then next, they will recognize the image. Okay, kids spend a lot of time. So kids spend a lot of time in toys. Kids spend a lot of times in, let's say, shoes department, and let's say in clothing also. So second, you will see the department will be for kids. And then people like you and me will come, definitely. The man will come, right? Boys will come at the last. They know they will take one t-shirt and, for 1 year, they will not going to purchase the next one. Correct, everyone? Just raise your hands if you agree to it. No one will raise, right? Oh, many. Thank you. Now, what happened is this entire predictions, they will make the men's department at last because they know the least revenue will going to come from here. And now just relate it. Now think about going to any mall and you will see the when you go to a cashing department or there, you will see the toy section of kids. Because if kids are there, either you want them to purchase or you don't want them to purchase. If they are with you, they will take toys. Okay, I need one small car. Okay, I need one soft toy. They have hundreds of soft toys at home. No, but they will take it from that place. This is actually all predicted. So this all have been happened under the hood using image recognition. In very big outlets, they do this research, and basis on that, what they do is they actually put these all racks or compartments or departments so that they can increase their revenue. It's one of the best examples. Again, there are many image recognition examples. Let's say there you are in a different country and there are thousands of people and there is one celebrity in between it. Now you want to recognize that celebrity. You can use image recognition. So there are many use cases to image recognition. Very, very popular technology today. The another one is drug discovery. Now, again, a very good use case, right? You can relate it absolutely, with the pandemic we had, couple of years back. If machine learning won't be there during the pandemic, trust me, I'm sure till date we would not be having the corona vaccination available. It's not easy to create drugs, medicines. It need huge investment. Once upon a time when I was thinking to become a doctor, now I don't have any capabilities to become thou. But at that point in time, some of the fellow people used to say the doctors spent their entire life to discover one drug. And if they are lucky, they will do it. Otherwise, no. Think about it. Entire life of a doctor is or researchers are gone to just create a single drug, medicine. Still, uh, it is not completed. Now you cannot do all such things. You need pace, you need speed so that you can do filtration, segregations, put multiple parameters to it, create a drop by drop or a scent by scent things to, create the entire drug. Now, artificial intelligence is actually working in this domain hugely to actually create the drug discovery. Even it is working in one of the fields in medical wherein it is creating personal treatment for people, understanding your entire background, your parents' background, understanding your genes, DNA. It is actually doing a lot of permutations and combinations and predicting what might go wrong with you in future. And to mitigate that, you can take precautionary actions. This is so huge actually. No one would have think about it, couple of years back. This is where the machine learning use cases or artificial intelligence use cases are going on in medical industry. Next, driverless cars. One of the best examples. Although in India, it will not going to come so easily. It's not easy basis on our road infrastructure. But yes, driverless cars. Driverless cars under the hood is actually using your image recognition only. Right? You are going, right? Here, so someone is sitting, driver seat is empty, the car is running, someone came in front of it, some human came in front of it, the image recognition will recognize it's a human, it's a man or it's a woman. What will happen is basis on that, it will make a break and it will stop. Likewise, you are going, there is a building. It will actually recognize that this is a building. It's an image of a building. So I need to take a right turn or a left turn. Okay, it's a red light. So the light is red. I need to stop. Okay, it is going green. I need to move. It will, from the sensors, it will actually sense 360 degrees and it will change a lane for us automatically. This is how the driverless cars are working. They are one of the best examples of, I would say, deep learning. Deep learning and ML both. Right? Next is personalization. The example which I showed you, Amazon.in, go and search for books, go and search for shoes, go and search for t-shirts, go and search for jewelry, and you will see all over the place you are going to get such messages. Even on your phone, go and open your browser and search something on your Instagram, on your Facebook, on your Twitter, on your whatever social media accounts are there, you are going to get similar kind of recommendations. Correct, everyone? I'm sure you all have noticed that. No, no one? Only PK. Oh, many other. Perfect. Now this is all because of this actually is because of deep learning. It's called recommendation system. So they learn from your behavior, your pattern, your browsing history, your clicks, and basis on that, it prepare the entire groundwork for you. Because it's actually going to help them to sell their products or sell their products. Perfect, right? Next. Now, AI life cycle. Now we spoke about lots of good things. AI this, AI that, examples, use cases, and so on and so forth. But it's not easy to achieve it. It's a life cycle. It's not that I'm thinking it and this application will be created. No, it will not going to happen like that. There are a lot of things which works under the hood. And there are multiple phases to it. So the first phase is called data preparation. You talk about AI, AI is all about data, tons of data. And when you talk about data, the data has grown exponentially from 2005 till now. Exponentially. And from 2015, it is growing with XXX amount of rate. And what we need data. So what we do is we do a data preparation. In ML, I'll tell you how we do a data preparation. Data is there, but we need to clean a data. We need to aggregate a data. So there are multiple phases and multiple steps which we need to do to prepare data. But the first step of AI lifecycle will start with data preparation. We need to prepare a data. Once data is there, we create a model building. We create a model to do a predictions for us. Right? So this data, using this data, we train our machines. And once that is done, what we do is we test and tune our ecosystem, right? So we build a model, then we are doing more and more training for it. We test it and we tune it. Once that is done, our model is ready. Example, GPT-3, they did it. They took most of the data, they created a model building, they tested, they tuned it, right? And they trained it more and more. And after that, once it is done, they deployed it. And once they deployed it, it became chatgpt.com. And now what they are doing, they are managing it. Earlier, it was GPT
अच्छा
3.5.
मांग
Can you please be on
रखा है
mute?
तो पढ़ेंगे
Yeah. So now they are managing it, model management, putting more and more features, learning and making their model more capable so that it can give you a real-time details as well, and so on and so forth. So when you talk about AI lifecycle, these are, again, the four are the primary steps: data preparation, model building, testing, tuning, and model deployment. You talk about ML, you talk about DL, you talk about Gen AI, all of the models are getting deployed and trained and built like this. You need data. With data, we build a model, we train them more and more, we test them more and more, we tune them more and more. Now, again, multiple terms will come when we come to ML, but at a very high level, holistically, this is what AI lifecycle is. Right now, it's time for demo. Now, what we are going to do is we are going to actually see multiple demos. We talk about image recognition, we talk about label detections and so on and so forth. Let us actually witness them. Let us see whatever we have understood, either it is true or not. And if true, that up to what extent it is true. So what I'm going to do is, let me go to, I'm referring the AWS platform in my case. Now these services are available across all of your cloud platforms. A little slow today. Let me log in with the root account. Right? So people who are familiar with AWS, okay. If you are not familiar, no problem. Just see, if I come here, this is a service section. Likewise, with any cloud provider, you will see their service sections. If you scroll down, you will be able to see machine learning here. These all are the categories, service categories. So if you see here, there is something called machine learning. So if I click on this machine learning, on the right hand side, you will see all of these are there: machine learning, deep learning, and Gen AI tools. Example, if you talk about this Bedrock is ChatGPT. We will see it in action tomorrow. If you come down, you will be able to see something called, see this, Amazon Rekognition. Search and analyze images. So I'll just click on it. Now, if you see here, if you want to learn it more, you have many things here. There are certain learning content. Some of the examples are also given here. Now, if you see this, let me close these tabs first, and then we will start with see this. How you can use it. See here, label detection, image properties, image moderation, facial analysis, face comparison. Now this is a new one, face liveness. How live your face is today at present point in time. You will say face liveness. Celebrity recognition, the example I was telling you. There are thousands of people and you want to recognize if there is any celebrity in between them. See this. Text in image, again, very useful, right? Especially in recommendation system, we use it, text in image. So you are having images, you want to extract keywords from it, right? PPE detection. I don't know what is this. I didn't use this. So if you see here, these all are the sub services which you can use. Example, we'll come to the first one. Um, let's say facial analysis. See this, or let's start with the label detection first. Better. See here, you already have one photo here, one picture here. Now, if you see here, there are certain blocks here. These blocks are labels actually. So in this picture, automatically your Amazon Rekognition have identified. See this, that this is a building. If you see here, this is a cars. This is a person. This is a stick board. If you see here, cars. Basis on this, now what happened? You give a picture. This service will automatically going to label the things, and it will actually going to tell you basis on those labels that what kind of picture this is. Example, if you come here, you will see these variables, and then you will see this as a confidence score. See this neighborhood 99 point. These all are neighbor. City, it's a city 99.9%. This image is from a city. Road, yes, there is a road. Street, yes. It's from urban. Yes, it's from urban. Person, yes, there is one person. 98.7%. There is one person also. And likewise, you will see many other car, transportation, vehicles, blah blah blah. So these are the keys or variables, and this is a confidence score. That yes, 100% it's a city. 99%. Yes, it's this photo is from a city. If you scroll down, there will be two things associated with it: request and response. Request is the input, the photo you are giving. So if you click here, see this, it's an image, and this image is coming from here, S3 bucket. So this is input. Basis on this input, it create a JSON response like this. See this, labels, those variables and keyword. These are labels. See this, confidence score. And then these labels, there will be dependencies also. If you scroll down, you will see something. If I come down, see this, parents. So it creates a dependency also. It's a street. Street belongs to a road, to a city, and to a urban place. So it creates automatically the dependency, the channels also. And basis on this JSON output, what it does is on console, it will show you a result. So this neighbor 99.9 is coming from here, from this response. See this, neighborhood 99.9%. Similarly, if you come down, city, this. So it is just taking the name and the confidence score here. See this. If you see here, there is another one, which is already here. Click here. So it will analyze it. See here, it is showing a tower. Come here. All those things, request, coming from S3 bucket. And if you see here, details. Now let us do one thing. Let us upload an image here. So let me show you. So I already created one folder here for you, and I've just kept a couple of things there. See this. So let's say this one, this image. So I'll just put this image and show you and see how the prediction label detection will happen. I'll upload, go to desktop, AI, and we have this one, the_1, open. See this. And if you see here, what it have done, it have automatically detected that this is a girl. See this. Person, 99.9%. Sitting, yes, sitting. It's a child. It's a female. It's a girl. Showing a head, face, happy, fitness. See here, sports. So it have automatically recognized football is there. It's a girl, right? It's a playground. So they are playing and so on and so forth. right? See this. So this is label detection. If you come here, I'll just show you one difference. As you know, I have just uploaded this. So you will not see anything here because we have just drag and drop, just uploaded it here. So if things are coming from a storage like S3, then you will see the location of that image also, right? So don't get confused why location is not coming, because we have dragged and dropped it here. We have just uploaded it here. Likewise, response, see here, same thing. Person, parent, sorry, come down here, sitting, child, and so on and so forth. And all these things will be here. See this. So this is how you can do a label detection of an image, and you can identify that image. This is one. Now let us come back and we'll go to facial analysis, right? See this. This is an image. Already it's an uploaded image. I'm not doing anything to it. This is already there. Now if you see here, looks like a face. So it's a face. Appears to be a female. Age range is this. Smiling, yes. See here. Same thing. Request. Image is coming from where? And then you have responses. All done. These responses here. And then you can recognize, okay, this image belongs to a face. That face is of a girl, mouth open, smiling, and so on and so forth. Let us upload another custom image here and see how it do the facial analysis for that. So I'll upload another image. Let's say a different one. Let's say this one, a different one. So I'm just uploading this. See here. Now you will see this. Looks like a face. Appears to be a female. Age range is 1 to 5 years old. Smiling. Appears to be happy. Not wearing glasses. Then you can write, oh, okay, yeah. So this is a facial analysis this AI service have done on it. You come down, same thing. As we have directly uploading it, so it's not coming from any external storage, and then you have JSON response. Likewise, text and image. See here. There is already an image. It's Monday, but keep smiling. Likewise, if you come here, another one is there. See here, J3. So it have automatically detected it. Let us test our one. Let's say this one. See this. This is one of the images, right? And if you see here, think 100%, 0%. And if you see, this is our logo. So it is saying you trust, we deliver. So we are not able to see here, but this AI ecosystem was able to see it, and it is showing it here. You trust, we deliver. So from any image, you can extract the text, and then you can do a permutation and combination and create your own slogan. This is one of the use cases in the retail industry or in any industry. Right? Likewise, you have celebrity recognition. See here. So Jeff Bezos, 99.7%, it's a Jeff Bezos. Come here, the other one, see here. Andy Jassy, so 99.5. Now you put any other image. Let's say I'm putting the same which we used. See here, it will say no celebrity faces recognized because this guy is not a celebrity. Right? But anyways, this is me only, everyone. So if you see here, no celebrity faces recognized. This is how you can recognize famous personalities from the pictures. Even there is another one. If you see here, face liveliness. Let us test it. Now it is asking me to enable my camera. Let me do it. Let us see. Allow this time. Okay, so if you see here, center your face. Let me do it. And start a video. Move closer. Okay. See here, it is verifying. Perfect. See this. Liveness confidence score 99.5%. It means I am 99.95% live. See here. See this. review the result, blah, 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 blah. See here. So this is how you can, now this is a fairly new one. So I just wanted to test it. So see here, you can check a liveness score, confidence score. See this. Useful, right, everyone? Yes, no? If yes, then raise your hands. Yeah, perfect. Now, this is how, again, this is all machine learning or deep learning under the hood. But as we are just understanding AI as an entire ecosystem, so I just showed you this one. Let me actually, before we start with the ML, let me actually show you another custom project that can actually help you how companies are using it, right? Because you want to see how people are putting things in storage, and from storage, how they are triggering it and using it. So let me actually explain you one custom project which I'm going to do in front of you right now. And I hope it will work. I didn't tested it, but I think it should work. What we are going to do is we are going to have a storage. Let's say we are going to leverage S3 only for AWS. And here we are going to create one bucket. So bucket is a folder, everyone, right? Just a folder so that we can upload things here. And what we will do is we will upload one picture here. And after that, what we will do is we will create one serverless driven event. So we are going to trigger an event here. Event to check either the something new is there in the folder or not. And we are going to use Lambda here. AWS Lambda, right? So we are going to have a bucket. We'll put picture and then we will say this event, hey, if we will trigger this, go and check if there is any new image or not, or any image, any data or not. If data is there, take it and give it to some other system. That some other system will going to be our AWS AI service, which is AWS Rekognition. So there will be APIs. We will integrate the APIs. We will write our Lambda function in such a way that it can integrate it with the open APIs of AWS Rekognition. Then we will say Lambda, you have whatever you have taken this image, give it to AWS Rekognition. And then AWS Rekognition will going to do a, let's say, facial analysis. We use facial analysis API. And then return this back to Lambda, right? And Lambda should show us the analysis report. Which is nothing, which is output of the facial analysis of image. This is one of the custom project I'm going to do live in front of you. Everything from scratch, right? So we will do this. We will do this. We will do this. I'm going to use a Python here. And you need not to remember. I'm going to give you a GitHub link. In that GitHub link, you are going to have the Python to trigger this. Python to export the Boto3 library and integrate it with the AWS Rekognition and S3. So I'm going to do this in front of you. Let us see. So let me have some water. Perfect. So we will use this image and come here. So we will go to S3 first, not here. Sorry. So we come to S3 and let us create one bucket, right? Bucket is nothing, it's a folder, right? So object storage. General purpose, let me give it a name called demo bucket. Let us see this name, or let's say AI demo bucket, right? AI demo bucket. Rest all of the things, let's keep as it is. As it is. So we are not going to do any other changes to it. Let it be all default. Create an bucket. See here, this name, okay, underscore is not allowed. So AI demo bucket. Create bucket. See this bucket got created. Now this bucket is empty. There is nothing. Let us put an image here. Upload. See here and see, you see add files. Add files. Let us give Dia one. So this one. Right. Click here and say upload. So this and upload. See here, upload is in progress. Upload is done. So if you see this, it's done. Come back to this. See here. Now we have our bucket, AI demo bucket, and we have an image called Dia JPEG here. So our first part is done. So if you come here, if I come here, see this. This is done. Now event. Let's go to Lambda. AWS Lambda. Let me open it in a new tab. Here. You can run your code without servers. It's called serverless triggers. So if you see, create a function. So I'll come here and I'll create a function. So I'll give it a name called demo function. Right? So we are creating a function so that it can trigger the thing, serverless functions. See this runtime. I will use Python 3.12. Let us have everything as it is, and we will say create a function. See this function got created, demo function. Come here. Now, before we do anything, we need to make sure, let me use a different color notation. We need to make sure this Lambda should have permissions for S3 and permissions for recognition service, right? So we do a user management. We will allow our Lambda to have access to S3 as well as recognition services. Otherwise, it will show us a failure, unable to read things from S3 bucket. So we will give relevant permissions first. Come back here. I think it should be in configuration. Yes. If I come to this configuration, you will see the summary here, resource summary. See this. Only one role is added, AWS CloudWatch logs. It means Lambda can just see AWS CloudWatch logs. What we need to do is we need to provide the permissions to AWS Lambda now. What we took for S3 and recognition. So if you see here, there is a link, role. Just click that link. It will automatically going to take you to IAM console. See this. IAM role, this role. Now what we need to do here is, see here, this role is having just permissions, basic permissions. So you see here, add permissions. Click attach policies. Click on attach policy and search for S3. See this? I'm just giving a full access for the timing. Amazon S3 full access. Click. Similarly, recognition. See this. Amazon recognition full access. I'm just giving these two accesses and I'll say add permissions. Come here, see this. So one was Lambda basic and we have give these two permissions also. Go back. It's not reflecting here. Refresh it. See this. CloudWatch. It was just CloudWatch earlier. Now if you see here, recognition and S3 is also there. Now we'll come back. We'll come back to code. What we want to do now is we want permissions are done. So tick mark, all done. Next is we want to write an event, and we are going to write that event in Python. So that if there is anything, if it goes to S3, if there is any image there, take that image and supply that image to AWS Rekognition service to facial analysis. We will leverage APIs here, which I will show you. Then Rekognition will complete its work, example, facial recognition or text to image or that liveness, whatever we have seen earlier, right? And it will going to give the JSON output. And then that JSON output will come here and we are going to display that here in Lambda functions, right? Now question comes Python. Again, we are not Python expert, let's say. So you need not to become a Python expert. Just go to github.com. Just go to my organization. This one. You will be able to see this section 1 and you will be able to see this recognition.py. So these all things will be shared with you. You need not to worry, right? So if you come here, section 1, this one. So this is something which we need. So I'll copy this. I'll come here. I'll come back here to my, right? And we will just replace this code here. Sorry. See this. We are importing two libraries, JSON and Boto3, and all explanations are done here. Then we are creating one variable, which is API, right? Boto3.client and recognition service. Then we are defining one function here, right? So we have to handle the means we are just going to a bucket and checking the things. So we need to change the bucket name here. We have created a bucket name with AI demo bucket. So I'll change it. AI demo bucket, right? So this one, AI demo bucket. Come down, name of the image. So you can put a name of the image as well here. Even you can put a loop also in case you want, but just to make it simple, I'm putting it in a simple hard-coded values. See here, the name is Dia. So I'll come here, I'll say Dia, right? Scroll down, see here. Now this is something which is important. What I'm doing is I have defined to take an image, but what to do that with that image? Now what I'm doing is I am doing see here, I am doing a facial detection. So for this, what I'm doing, if you see here this, I'm leveraging the API. Now question comes, how can I be able to put it? You need not to remember it. What you need to do, just go to the Google and say AWS Rekognition APIs. See here. API reference, these are all publicly available APIs. If you see here, come here, just click on this reference. For every service, you will be having the APIs. And if you come here, what we are doing is we are using detect faces, this one. If I click, you will see everything here. Scroll down, see this. Request syntax, parameters, and all. How it will going to give a response, right? See here. Facial details, blah, blah, blah. So what we are doing, we are actually using this only, nothing else. See this, detect faces. Come back, see this, API.detect faces. Then you have image, S3 object, bucket, name, attributes. This is all coming from here. See this, image, image. Under image, we have S3 object. See this. Image, under image, we have S3 object. It need bucket and name. So bucket is coming from S bucket and name is coming from this image. So we are replacing these variables from here. So if you come here, see this, then you are having bucket and you are having name. And in case you want other variables, you can put other variables as well. Right? We are putting it for all variables. We want everything to be detected. And then what we are doing it, we are putting it in a loop and we are giving intent of two, means two spaces. So find all details of this phase, not only a single detail. Right? So we are putting it, then what we need to do is we just need to deploy it. So if you see here, now what we have done, event, we wrote a Python trigger. That Python trigger is going to this bucket, checking the things and providing those things via APIs to Rekognition. And then Rekognition will perform the things, send the result back, and we will be able to see it. So let's do it. Let's deploy. Right? Once deployed, see here, we are going to do a test. Let's say I'm giving it a name called demo test. Everything as it is, just say save. Now run a test. See here, it is checking all those things and it is providing us the detail. Now let us come back. We used the this one. So this image we have used. Now let's see either it is giving us a result appropriately or not. See this. Age is 1 to 5. Smile is true. Eyeglasses, no, it's not there. Sunglasses, no, it's not there. Gender, female. Beard, no, there is no beard. No mustaches. So if you see here, it have recognized that image. It have done all those things and given us the result. Now this is all JSON format output. So we created this custom project for us. And once your work is done, right, you can delete it. This will going to, such kind of things will going to be homework for anyone who want to test the things. Once your work is done, just remove it. Come here, delete. And these are all free. You need not to pay anything to cloud. So it comes under free tier. Come here, come to your Lambda function. So we have deleted everything. Similarly for your bucket, right? So it's gone. It's gone. So come to your bucket, delete the objects from it first. Permanently delete object. And once the object is deleted, you can delete the bucket as well. Click. You can give AI demo bucket, delete bucket. All done. Nothing else is required. Right? So just in a nutshell, what we did, we created a sample project for facial detection, wherein we have put everything in the S3 bucket. We leveraged AWS Lambda, right? We put the image, triggered the event, took the image, give that image to the Rekognition. Rekognition have done the AI part of it in detecting the details and then provided us the results. This is what actually we have implemented. Same thing you can scale to multiple images. Same thing you can scale to whatever services were listed in the AWS Rekognition console. Similar things are absolutely applicable to other cloud platform as well. And even you can create your own models and algorithms to do such things, obviously. So now what we will do is, we did this demo. Yeah, I think we'll start with the AI domains, but I think as you are listening since last, I think more than 1.5 hours, 1 hour, 45 minutes, better we can take a quick 15 minutes break, because once we come back, we are going to get started with ML. Clear, everyone? So is it useful so far? Yes, Vishwendra have asked a question. Is it possible to choose characteristics that we want to recognize? Yes, there are custom labels which you can put. Even in AWS, when you go here, you will be able to see a custom labels tag. Let me show you. If you come here, let me go to Rekognition. So if you come here, you will see this thing here, custom labels. I have just hide that earlier, this one. So these all are the models and the labels which AWS have already incorporated in their models. If you want to customize those things, you can put or use custom labels. So yes, you can. Perfect. So there is one question, very good question from Archana. Are there any tools available to detect if any content or image, text, etc. is AI generated? Very nice question. So this is where many organizations are working, Archana. It's a very good one because this comes under the ethical considerations of AI. So now what is happening? I'll give you one very simple example. So there is one company, they are creating one software. I'll again not disclose the name of that company. What they are doing is they are creating a software to do the assessment and interviews of candidates. So the first phase of their software is to go and search for the profiles from portals like Naukri.com or LinkedIn or wherever. So now the problem they were encountering, again, a month back, I was discussing this use case with them. So they were saying the people are so intelligent that the profiles which we are getting is created via AI, and it is getting difficult for them to detect either the created profile is a genuine profile or AI created profile. So yes, it's a problem at present point in time. There might be some tools, but I am not aware of that, right? But yes, this is a place wherein many organizations and companies are working to develop products, and it comes under ethical considerations of AI. So it's one of the risks also you can think of. I hope this is okay, Archana. Okay, so now there is one thing, everyone. So I'm sure every one of you have understood the holistic AI ecosystem. So now this is test your knowledge. Now, what I want as a homework, whenever you get time, not today necessarily or tomorrow, whenever you get time, maybe this week or next week, what I want you to do is just create your AWS free tier account. Absolutely free. You need not to pay anything, right? Because most of the AI services will give you, the free tier level access so that you can test many things without paying anything to AWS or any other account, any other cloud. So I want you to, do these three simple things. Thing number one, let me take it here. So if you come to this recognition service, I want you to test label detection. So I'll just copy this. Um, Let me take it like this, right? So go to recognition and perform below tests for AI. The first one. The first one I want you to do is label detection, right? Put any image of your choice, any image of your choice, and see if you get the desired results, accurate results. Now, let me tell you, even 6, 7 months back, the accuracy was not very good. It was not actually very good, but now they are improving. And even Archana, I think there is one Hari Krishnan have just sent you AI generated text detector example. So quillboard.com is one of the one. Thank you, Hari, for sharing it. the second one, right? If you come here, you are having facial analysis. So you can do this also, right? Put any image of your choice and see if you get the accurate results. The third one, I want you to do this. Text in image, as well as celebrity recognition, these two. So text in image, put any image which is having text in it and see if you get only tests. The fourth one is this, celebrity recognition, right? Put any celebrity and non-celebrity both. And check the results. And then sample project, the one I showed you. So S3, Lambda, and AWS Rekognition. We refer the Python program from here. So I'll come back here and I'll give you this link. The entire repo under this section 1. Simple one. You have to create S3 bucket and put any sample image in there. So this is what I want you to do for you. I have just pasted this whole in the chat. So everyone, please, whoever want to do it, try to do this. It will be a good one for you to actually have some hands-on exposure on checking the things. So again, for Archana's question, I think Hari have shared one. So this is the one, Quillbot AI content detector. So add text to start. Perfect. So let us test it. Create a poem on winters with 20 lines. Let us test it. Archana will just check it for everyone. Probably it's a good one. It's a good use case actually. So I'll come here, AI detector. Now what I'll do is I'll tweak it a bit. Right. So I'll come here, VI sample check. Let me tweak it a bit with some word. Because this is what people does. They tweak it and then test the bots. A moonlight. let's say rice. The world transforms to okay, let's take this and test it out. So I'll copy it, come back, analyze test. Let's see. If you see here, 100% of text is likely AI generated. Right? So great one, Hari. Now let us do one more thing because we'll test this entirely. So if I come back, just 1 second, we'll test it out. So this is one of the chapters from my book. So let me take something from it because this is all written manually. Let me take something. Let's say the first line. Minimum 80 words. Perfect. Now, if you see here, this is not correct one. Archana and Hari. So if you see here, this is saying this is AI generated, which is wrong. This is entirely created word by word by us. So we haven't used anything and it is published. And if it would have been created using AI, then it would have been detected in their ecosystem and this chapter would be neglected. So again, it's a good reference, but do not completely rely upon it. So everyone, if you see here, it's just saying that 14% is human written. Now it is 100% human written. This is edited by the editors of the publication. Now, again, one more test that probably will prove us either this tool is good to go with in order to use it in future or not. Let me go to this one. Let's say I'll take something from it. This is little old one because this feature is removed from AWS now. But just to test it out, let us see. Now, if you see here, this is showing all human written. So this is a correct, accurate one. So sometimes it is showing a right result. Sometimes it might show here and there. So be very careful because this is something where lot of research is going on, lot of efforts are going on. but I think yes, we can use it as a reference. Thanks, Hari. Archana, you can use it as a reference, but be very careful. Perfect. So let me close all this, and let us switch back to our context. So homework, everyone, is given. So if you want to test it out, you can test it out. Now let's get started with our next part. Which is AI domains. Now, so far we have seen many things which we were saying AI, right? So what we need to do is AI is just a label. Under the hood, the things being performed by other AI ecosystem. Now, example, now when we talk about this entire world, that world can be considered as AI. Inside that you have, let's say, India. India is something else in that AI broader ecospace. Inside India, let's say we have Chennai. So Chennai is again a subset of India, something else. Inside Chennai, we have a specific area. That area is again something else. And in future, it might be many other smaller things which comes inside it. Likewise, the AI ecosystem also works in the same way. Now, when we talk about, let me come here and show you. Just give me 1 second, everyone. Let me remove everything which is not required. Now, when we talk about AI, so AI is a big, hypothetical layer which exists every. We talk about ML or DL or Gen AI, everything is AI. In simple layman language, everything is AI. So AI is just a label. Under it, you are going to have other things. So the first other thing is called ML. You will never see AI alone. You will always see AI and ML. AI is a name and ML is an algorithms which are actually performing the tasks. Whatever examples we have seen so far, they are actually from either ML or DL, but they all termed as AI examples because as a layman, people cannot understand what is ML, what is DL, what is Gen AI. For them, everything is artificial intelligence, right? So this machine learning is something which does the magic for us. And when you talk about this machine learning means to learn something. So from where to learn? To learn, you need a data, either data or data sets. It's the same thing. So we are talking about tons of data. Now, whenever you are talking about a data, example, if I ask you to create an Excel sheet with blah, blah, blah things and give it to me, everyone will going to create a different Excel sheet. Someone will be having 3 columns, some will be having 4, some will be having missing values, some will be having all values, some will be having extra values. So data will be all different. Example, if I ask you to search about AI on Google, you are going to get different data. Some will be good for you, for your understanding. Some you might say, oh, I'm not able to understand it. Right? Likewise, when you talk about data, there are two types of data actually. One data is called structured data. Right? So one data is called structured data. And the other type of data is called unstructured data. Similar to Excel sheet. Someone is giving me an Excel sheet, proper formatting, column A, column B, column C, all 1, 2, 3 lines, blah, blah, blah. Everything is there. And someone is giving me an Excel sheet, which is having column A, column B, column C, and then let's say they are having rows 1, 2, 3. Some values are missing, some values, and then 2, 3 blank lines, and then number 6, and then something, something, right? Like this. So this is called structured, and this is called unstructured. Likewise, when you talk about data, data might be coming from multiple sources. It might be a structured data, it might be unstructured data, a good data or a bad data. Now, when you talk about a good data, it is easy to use good data. Correct? I'm sure everyone will agree, right? If you are getting a good Excel sheet, yes, it will it will save my time. But if you are getting a bad Excel sheet, you need to rework. Likewise, when you talk about machine learning, there is a different type of data, structured, unstructured, good, bad, or you can say labeled or unlabeled. Labeled and unlabeled data. And basis on this data, right, what machine learning will do? Machine learning will actually going to create different type of learnings for us. Yes, please. Can you please be on mute? I think someone is on phone. Can you please be on mute? Right. So see here, we have ML and we have machine learning. Again, everything is data. We have a structured data or labeled data or good data, or we have unstructured data, a bad data, where we need a lot of work and rework needs to be done, a lot of cleaning needs to be done, which is called unlabeled data. And basis on labeled data or unlabeled data, or in a layman, structured data or unstructured data, there are types of learnings. And basis on that, we develop models or algorithms. So you have supervised learning, unsupervised learning, and reinforcement learning. Let us understand it. Very simple, with very simple example, right? So I'll come back here. So types of learning. It's very important. Types of learning. So we have three types of learning. And these type of learnings, again, completely depend upon the data, type of data. So the first one is supervised learning. I'll give you a best example of it, right? This conference is a best example of that. A teacher teaching someone. Now, with my experience, what I am telling or what I'm explaining are the best use cases or whatever I have experienced so far. So I'm telling you so that it fits in your neural network in your brain and you can further explain it to others. This is exactly how supervised learning happens. A teacher is teaching everything to a computer and then computer make the decisions for us. Another example, let's say we are having fruits. Let's say we are having an apple and we are having a banana. What we will do? We will put certain labels to this. Apple is round in shape. Apple is red in color. Similarly, what we will do is we will say banana is curvy in nature, right? And we will say banana is yellow in color. These all are the parameters. These are called labels. It's called labeled data. And then we give multiple fruits to multiple fruits. Let's say fruits 1, 2, 3, 4, 5, 6. You are having guava, orange, apple, banana, grapes, and pomegranate, and so on and so forth thing. Now we will ask computer to actually segregate apple from it. Basis on this, whatever we have taught them, whatever they have learned, what they will do is they will apply that here. And then they will put this, okay, this third one is an apple. Why? Because my learning algorithm says it's round and it's red. So this is an apple. Likewise, this fifth one, let's say this is a banana. Because my learning algorithm is saying it's curvy and it's yellow in nature. Perfect, all done. This type of learning is called supervised learning, where we train our model on labeled data. Many examples. It will come next. I'll show you. Next one is a unsupervised learning. Now, how many times we can expect a good data? Let's say if we are very optimistic, 50% of the times. Because the source of data is diverse. It might come from internet, it might come from some other trusted sources, it might come from some databases. So we create a data lake and then we'll do all those stuff. Likewise, 50% of the times we will assume, right, which might be more, that we are going to have a bad data, unlabeled data. Now, if we are having unlabeled data, it is very difficult, to use the same models to do a prediction for us. This is where unsupervised learning will come into a picture. Unsupervised learning. Now, in unsupervised learning, what will happen? Instead of identifying the objects or the final values, what we do is we segregate things in groups. So what we do is just writing for your reference, this term groups, grouping, clustering is something which happened in unsupervised learning. Now, let's say we have huge data and we have consider multiple fruits. Let's say we have an apple, we have banana, we have orange, we have guava, we have let's say some vegetables also, let's say cucumber, and so on and so forth. Now now this is all unlabeled data. Now what happened in unsupervised learning? What it will do is it will actually segregate things into a group. It learn itself. Okay, apple, round, color, size, and so on and so forth. So it's segregated here, apple. Similar to apple, orange, round. Okay, orange. Similar to it, round, we have guava. So it will put them in a single group and create a group out of it. Likewise, what it will do is it will segregate. Let's say you have banana and you have cucumber. So banana and cucumber. So it create a group and then you work on that group, do the predictions and do the things. Best example, recommendation systems. They are learned from unsupervised learning only. The entire models will be unsupervised models. Means the type of learning is unsupervised learning. We will shed a light to it next. Another example, let's say you are having a bunch of balls. So some small balls, some medium balls, some large balls, some extra large balls, right? So what will happen? Different colors, different brands. What it will do? It will do a grouping, unsupervised learning. Small, medium, large, and extra large. And then you can run your models to do the prediction. So small, medium, your large, and your extra large. Likewise, now the final one is reinforcement learning. Now reinforcement learning is actually one of the most difficult one to train. Means time consuming, not difficult, I should say, but time consuming. Now in reinforcement learning, what we do, we want computers to learn themselves without being explicitly programmed. We want them to learn automatically. Example, there will be rewards or there will be punishments. So we will be having rewards and punishments. Example, it's like training a pet. So when you train a pet, you give pet different tasks. Example, pick a ball or run there and come back and so on and so forth. So if those tasks are being completed, those pets will going to be rewarded. If no, then they will be punished. They will not be rewarded. So likewise, we develop our computers. It takes time because every reward will add a learning mechanism in them. Then more rewards, more rewards, more rewards. Then filtering of punishments, filtering, more rewards. This is how we train our model. And then we put some more test data to it and test them, and then we finally release it. So with every good thing, you will be rewarded. With every bad thing, you will be punished. This is how we train our model. This is called reinforcement learning. Majority of the times in ML ecosystem, you will come across supervised and unsupervised learning types. But there is reinforcement learning as well. Now comes, these are type of learnings. Using these type of learnings, we build models, algorithms. Now, I hope that should be next. Yes, learning algorithms. Now we know supervised, we know unsupervised. Now, basis on that, you have in supervised learning, there are two major learning algorithms involved. Those are very good terms to understand. One is called classification and one is called regression. So I'm just specifying classification here. Regression will be next. Likewise, when you talk about unsupervised learning, there will be something called clustering, right? So we will be having classification algorithms basis on which we will going to make our models, and clustering. So for clustering, we need unsupervised type, means unstructured data, and classification structured data. It means we are going to get numbers or values here, and here we are going to get groups. Simple, right? So when you talk about classification, again, as I told you, it's unsupervised machine learning, right? Now what it will do is, again, in classification, it create classes, different classes, and provide a discrete value to us. Example, very good example. If I come here, right? Email spam, email spam filtering. Now I'll show you. Let me bring here my, see this. So this is my email box. Now, if you see here, there is something called focused and there is something called others. So this is focused one and this is others. Likewise, if you come here, you will see junk email, many junk emails. See this. Now question comes, did I created any filters manually to do these things? The answer is no. I haven't done anything, right? I haven't done anything to do such things. Then how is it working? Is it working because Microsoft have automatically enabled and put these things in Microsoft Office 365? Likewise with Google Suite or Google Workspace, you are going to have such things. Now, how is it working? In the past, 10 years back, we need to create rules in our mailbox, create a rule. If sender is this, put this in this group, blah, blah, right? So, but now how is it working? This is all working because of the classification algorithms, which is a part of machine learning. So this all happens because of that. So whenever an email is coming, automatically, because of, now again, email is coming, now that is having actually structured data, labels, names, content, multiple things out of it. So what will happen is your classification algorithms will going to take a decision, yes or no. It's a spam or it's not a spam. If it's a spam, put it in the junk folder or spam folder. No, then put it in the main inbox. Likewise, other example, your face recognition, which we have seen. Face recognition is one of the best examples of classification algorithms, which under the hood is nothing, a supervised learning type of machine learning. So face recognition is the same thing. A man or a woman or a kid. So you have face recognition. Even one good example which I came across while working with one of the banks, the loan approvals. Now, remember in past, if any one of you have applied for a loan, again, it's evolving. It's not that much evolved, but it's one of the use cases of classification algorithms. Now, when we talk about loan approvals, we need to give multiple documents, upload multiple documents, and then they do a validation of it and see how frequently this person is applying a loan, what is the credit score, will this person will be capable enough to return the loan installments, and so on and so forth. And then basis on that, they do a decision and say, yes, give a loan. Now, these all are human predicted. Now we are having machine learnings in it. You upload, now again, this used to take 10 days of time, assuming just approximate. Now you apply for a loan, within a couple of hours, it will be either accepted or rejected. Why? How? This is where your ML came into a picture. And ML under the hood is using classification algorithms to actually do all such things for us. right? Now, when you talk about classification, there are different algorithms also, means different models under the hood. You have logistic regression, decision tree, KNN. So there are many algorithms which runs under the hood. And basis on what fits your requirements, you can take those and you can customize or tune your model to do the tasks or predictions for you. This is entirely what classification supervised learning algorithms works, right? The next one is clustering. Now, when we talk about a clustering, it works on unsupervised learning, unstructured data. As I told you, groups. It will just going to create a groups for us. Those groups can be for, see here, similar things, or those groups can be for different unrelated things, but it will going to be a group. And then on that group, you actually do uh, predictions. There is very one, I remember one very simple example during my learnings when I was learning these models. So let me give you an example. Let's say a company is having three products, product one, product two, and product three. Now, product one, product two, product three, let's say different one. Let's say this is a video game. This is a television. And um, let's say this is a air conditioner, or let's say washing machine. I think washing machine would be a better example. Now, what happened? We will going to get the data again, because if you want to do the predictions, you need to have a data. Let's say these products are there in the industry since last 10 years, assuming, and we are having a 10 years of data with us, right? From different sources, from internet, from other databases, from some companies' databases, blah, blah, blah. So we have 10 years of huge data. Now what we do is we actually put that data to an algorithm. And what that algorithm comes up with, something called, let's say, from age 5 to age 20, let's say, right? It comes up with something, this group. And then it comes up with a group of, let's say, 20 plus, right? And then it comes up with something called here also, let's say 20 plus. But it puts something else in this group. Let's say 5 to 20, but usually kids. This is the age. 20 plus, but usually men. 20 plus, but usually women. And then it says this data, this type of category is actually using video games more. And let's say it predict and it tells that it is 25% of the total volume of data which I got. Then television. And it says this is for televisions and 50%. Or let's say 40%, because we will segregate things 40%. That 40% means there from this data, 40% of the people are watching televisions with, and majority of the people are men. And likewise, washing machines. And then here we have 40, 25, 65, 35. Right? 35% of the, this data belongs to women and they are using washing machines. Now, basis on these predictions, there will be multiple things which happens, right? The first one out of it is recommendation systems. Recommendation system. So using this algorithms, recommendation system will be created. So these age group, right, 5 to 20, if they are using mobile phones, you will see video games as a recommendation will come to them. Men, they are using mobile phones or laptops, TV will come to them. So men, kids, video games, and then if women are using washing machines. And basis on it, even that organization can plan that we are going to produce more TVs, we are going to produce more washing machines, right? If in case we are producing less video games, it's okay because it's just 25%. Let's focus on this area first. Right? This example, what I'm giving you is called market segmentation. So recommendation systems, one use case, marketing segmentation is another use case. These all things works on clustering. The data, which is unstructured data, unsupervised learning. Right? Let us come back and see here. The clustering is a type of unsupervised learning on unstructured data that involves identifying group within the data. With similar taste or different taste, doesn't matter, but it will all going to be grouping. So recommendation systems, market segmentation, and many other things are there, right? They are the best examples of clustering. So K-means, DB-scan, divisive, even I think KNN can also work here as well. So these are some of the one. Now again, another thing where people usually get confused. There is a term called regression. Now, this is okay. Classification, supervised learning. Clustering, unsupervised learning. So algorithms which belongs to clustering, it means we are having unstructured data. The algorithms which belongs to classification, models which we are means we are having supervised learning. But there is another thing with supervised learning. We have two things associated with it, and usually it create confusion. One is called regression and one is called classification. And their models are different. Their use cases are different. We have understood classification as of now, right? Wherein we are putting mail as a spam or not, right? Loan approvals, right? And so on and so forth, right? Now, when we talk about regression, now regression means average, right? Always average. It will not going to give you a discrete value. It will just going to give you a continuous value, right? Difference. Discrete value means classification. We are getting yes or no, right? But when you talk about continuous values, right, which relies upon independent factors also, not only the dependent variables of the data, that is where regression type of learning will come into a picture. It's again a part of supervised learning, but it is having a different use cases to it. Here you are going to have a continuous data, continuous real values, continuous. It's not one time, two time, no. Now, when you talk about your weather forecasting, you talk about your rainfall predictions, you talk about your house pricing predictions, you talk about stock market, they all are using regression type of learning because there are continuous values, right? So always remember, right? There are, I think spelling is wrong. Yeah. So always remember when we talk about learning algorithms, regression and classification, they belongs to supervised learning. Clear, everyone? Yes, no? Just raise your hands. These are important. Always remember in machine learning, these terms are important. It's not that you need to remember everything, but these 5 terms will be very useful for you to remember. One is supervised learning, right? Supervised means structured, labeled data. One is unsupervised learning. This is unstructured, unlabeled. And when you talk about here, two things, classification, algorithms, classification or regression. They might have multiple algorithms, right? But broadly we say classification algorithms or regression algorithms or classification models or regression models, right? But they have further many algorithms. Example, logistic regression is one here. Decision tree is one here. And when you come here, you have linear regressions. You have ridge regression here. Lasso regression is here. Many. Likewise, unsupervised learning. Always remember clustering, grouping the data, right? So it might have multiple algorithms. Example, k-means is there, right? So basis on this, we now this is all models. You can say these are machine learning models. In very layman language, these are machine language models. So your machine language model will fall one of them. In fall in will fall in one of them. You might give it a different name, but it will going to use one of these algorithms, unless you develop something out of the box. Now, next thing. Now, this is all good. We have so many use cases, but question comes how we develop our models. There are multiple stages to it, as we understood earlier also, right? AI stages, AI life cycle. Now, the first one out of them is data preparation, one of the crucial steps. Data preparation. Now, data is coming from multiple places. There is a life cycle of a data here. Before we consider it as a clean data, we need to clean a data. Simple. Unless and until it is not clean, nothing will happen. If someone will give us tons of files and ask us to read those files, it will not going to make any difference to us because we don't know the context out of it. Even if we give it to someone else, it will not going to be very helpful for us. This is the reason before you do anything in machine learning, you need to prepare. You need to have data preparation done. And there is a life cycle to it. The step number one is data cleaning. Example, data is missing values. Data is having blank details there. Some places, comma, comma, comma in single line is there. Some places it's not there. So you actually clean your data. First thing, we need to clean our data so that it will be a streamlined data. Once that is done, now data is not coming from a single source. Data is coming from multiple sources, from internet, from some of the commercial databases, right? Even in within the organization, the data is coming from multiple places. You are relying upon internet also, and you're relying upon SQL, you are relying upon your other databases types, and so on and so forth. So what you do, but that data is something which you use to train your models. What we need to do, we need to do a data integration. Another important step, integration. Once this is done, now we have tons of data, huge data. Now there will be duplicacy. There will be some irrelevant data. What we do? We do a data reduction, noise reduction. It's called data reduction. All unwanted data, repeated data, right? Junk data, we will remove. And finally, what we do is we create aggregations. We'll be having data aggregation, average, sum, multiplication, or whatsoever. So data aggregation will be there. Once these four steps are done, we will say we have relevant data. Relevant data. The more relevant data you should have, the more accurate models you will be going to build. Very simple. The more accurate data you have, the more accuracy of your models in predictions will be there. So this is one of the crucial steps and most important one. Once this is done, then we go to other things, model creation, model training, and model testing, right? So what we will do is we will going to create our models. It's called model evaluation or evolution. So what we will do is we will create a model creation. We will take this data. Let me use different notation. And we will start building our models. And what we'll do is with this test data, we will train our model. Right? It's a cat, it's a dog, it's a different animal, it's a rat, whatsoever. right? It's customer A, it's customer B, it's customer C, it's product A, product B, product C. These all are the means you just going to train your model with reference to your requirements, your expectations, so that it can do a valid predictions. It completely depends upon a type of data and a type of application you are going to build. Once it is trained, now then the time will come wherein we will do model validation, which is called testing. Right? So once it is trained, we will test our model. Either it is giving accurate results or not. In this phase, even we provide some out of the box extra data also, which was not in the part of a training. New data, fresh data. Fresh data. And test our model on new data, how it is performing. Either it is giving us the right results or not. If yes, let's move forward. If no, major, let's say 50% errors, again, you are going to go back and you are going to train it. Change strategies, change things, change your model parameters, again, come back and then do it. And let's say this time the testing is going well. You gave another fresh data, let's say fresh data 2. And the accuracy was good. Let's say it was 90% this time. And after that, to make this accuracy more, what you do is you do hyperparameter training or tuning. So the fourth step will going to be tuning. Tuning will be having two things. One, tuning parameters as per our desired requirements or application. And second thing is tune to have this value increased from, let's say, 90% to 95%, the accuracy. So you do a tuning with hyperparameters, right? So data preparation, crucial step, model creation or model evaluation, wherein we do a training, then we do a testing. We do a testing on a fresh data also, so that we should not end up in our application where the application is showing a good result with the training data, but without training data, with real data, it is showing something else. So we put extra fresh data multiple times in order to evaluate that everything is working as per our expectations and real predictions. Then finally, to have it further tuned, we use hyperparameter scheme or hyperparameter tuning, wherein we actually do two things here. We increase accuracy by putting more tuning parameters, and we align the things with our application. Now, there is still a problem, and that problem needs to be understood pretty well. Now you will always hear two terms. I'll write here only so that you can have everything on a same board. There is something called overfitting. And there is something called underfitting. These are very renowned terms in ML models. Overfitting and underfitting. So when you talk about overfitting, which clearly signifies that whatever model you have built, that model is more accurate with the training data. But with the real data, it is not as appropriate. It means you overtrained your model on testing data or training data. This is very bad because it will not going to perform well when it comes to real applications. Likewise, you have under, as the name says, over and under. Over means more training data, under means less training data. Now, underfitting means you have less trained your model, and it is actually not performing well because it don't know what to do. So you need to make sure to make a balance. Your model should not be overtrained and your model should not be undertrained. So it should not come under overfitting or underfitting. It should be balanced. Now I'll tell you one thing, again, a real thing. When you talk about AI, you will always going to hear something called bias. Example, one company have created um, one application which is using one model. They have developed that model as well. And some ABCD company have done a tie-up with them for their products. Whenever things are coming, our product should always be the best. Either they are best or are not best, doesn't matter. But whenever someone is taking or referring your models and your applications, they should always say our products are the best products. Now, this is called biasing. So they train their model with overfitting so that every time it will actually going to bias and it will always going to say, okay, this product from this company is always the best. Now, this is one of the biggest problem in AI ecosystem, biasing. Lots of work is again going on. We hope it should be resolved, but biasing is one of the risk factors in AI ecosystem. And this is how it happens. They train the models so well on training or testing data by injecting their products more and more and more and more, which will eventually going to show the same thing to the customers if they are using such applications. Right? Let me actually take you through this, what we understood. Data preparation, data cleaning, as I told you, we need to replace missing values and all those things. Data integration, so data is coming from multiple sources. We integrate the data and create data lake. Then data reduction, so whatever is extra, whatever is junk, whatever is not required, whatever is duplicate, we do a reduction of that. And finally, we aggregate it. Once this is done, the next thing will come: model evaluation, validation, and hypertuning parameters. So we do model evaluation, right? Means we create model, do such things. Then we do a testing of our model, which is called model validation. And finally, we put hyperparameter tuning parameters to it. During hyperparameter tuning, sometimes again, the biasing might happen from here as well. So people inject their parameters more. So this is where underfitting and overfitting will come into a picture. So overfitting trained more closely to the training data, and overfitting is more training data, and underfitting is less data. And both of the overfitting and underfitting are going to lead improper results. Next, before we jump into the machine learning demo, let us understand some of the use cases also, probably which can help you understand the things. Customer feedback analysis. So when you talk about satisfying your customer, now again, as a product company, so you are getting a lot of feedbacks, right? So you want to do a deep analysis of the customer feedbacks. This is where your machine learning will come into a picture. This will be very helpful for you to retain your customers. The other one is super cool example, predictive maintenance. Example, again in IT, I'm just taking it in case of IT. Let's say you are having you are having a data center and you are having multiple servers running in it. You are having load balancers, you are having network, you are having storage devices, you are having firewalls and many other things. Now you get to know about an outage in a hardware when the server actually crashed. Let's say CPU failure, memory failure, network cable issues, right? Let's say something wrong in the equipment of your Cisco firewall, or let's say Cisco devices, and so on and so forth. Now, many companies are working in order to predict such things in well advance, so that before the failure occurs, we will be having the prediction that this might happen, and we can do a proactive measures to it. This is particularly very useful in manufacturing domain. Reason being because if in manufacturing domain, if their chain is stopped, it means it will going to lead huge loss to them in a day. Because everything is, they use a Kaizen process. So everything is streamlined. So one thing will get created, another thing will get created, another thing will get created, and so on and so forth. And everything in manufacturing is machines or are machines. So if everything is a machine, definitely they need a maintenance. So what they do, they use machine learning models to predict the failure in their supply chain, in their pipelines, in their flow, so that they can do the predictive maintenance accordingly. Next one is image recognition. We have already seen this in the AI examples as well. So image recognition is also one of the examples of ML, and even it comes under DL as well, because driverless cars is an example of DL and it uses image recognition at the end. Demand forecast. Now it is anything. It can be a demand forecast, it can be a weather forecast, it can be a stock market. Stock market primarily, more inclined towards DLs in a way. But when you talk about weather forecasting, demand forecasting, these kind of forecasting things, example, house rate forecasting, all such things, they all come under your machine learning. Transportation, lots of things are going on, right? Again, it's a big pain in many developed countries and developing countries. Traffic, right? So red lights are created in such a way that they are programmed for 60 seconds or let's say 90 seconds in each of the direction. So we are making our ecosystem so smart that it can analyze the data and it can remodify the timing of green light or red light automatically as per the demand, as per the traffic at that area at that point in time. Example, in morning hours, from direction, let's say from east direction, there is a huge traffic, but from west, there is less traffic. Then the green light will automatically be less in the west direction and more in the east direction. So such kind of lot of innovative applications are being under testing phase. Even in our country, in India, lot of development is going on under the transportation ecosystem. But again, there are certain prerequisites to it. That is infrastructure. One is infrastructure out of it. So this is where things will happen. Another use case is when there again a real case. Example, there is an accident, and because of that accident, things are the traffic is getting jammed. So you can have ML in such case to analyze the traffic pattern, redirect them here and there, and do a lot of stuff. So a lot of investigation is going on under this area, and you will see a lot of things will be implemented in India as well for this. Risk assessment, obviously, the frauds, fake transactions which are happening. Many people, internet banking passwords, they are getting hacked and so on and so forth. Using a dummy credit and debit cards, a lot of permutations and combinations are happening. So in finance, from where the traffic is coming from and how it is coming, the nature of that traffic, basis on that, they block the things. So this is where the ML is actually playing a very good role, right? Now, let's jump into a demo. So I think we can jump into a smaller demo first, and then we can jump into a little little complex one. So this one. So what I'm going to do is I'm going to show you some of the one of the very simple examples so that you can actually understand how machine learning is actually happening and how people are creating softwares to do the things. Now there is a software called a data analysis, Datasquirrel, which can be used to do a data analysis. It will predict the things. It will go beyond that and create a graph for us. So I am having a dummy data with me. I'll share it with you all people so that you can also test it out. So if I again go to my desktop, AI ecosystem, not here. Yeah, it's here. See here, there is a data, sales data Q1 and Q2.csv. Let me open this. Looks to be a big file. bring it out of presentation mode. Where are you? Yeah, I think it is opening on my other associated screen. Yes, see here. Now this is the data, right? So order reference ID, product ID, name, user ID, product name, product category, right? Well-structured data. Order name, quantity, unit price, revenue, payment model, and zip. See here, state, zip code, city. Now, if you come down, 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 see here, it is having a purchase history, sales history, right? See here, footwear, apparels, eyewear, many things from different country, different people, different names, and all. So it's a huge data. See this, right? How they have taken it. It's a credit card or it's a cash or it's whatever. So multiple means we have multiple details available with us. Now, what we are going to do is we are actually going to leverage these details. And we are going to use one of the tools, which is called Datasquirrel. It is one of the application developed by one of the external company. So it's a simple example, and hence that's the reason I'm taking it. So I'll just take this. I'll come back to a browser, let's say here, and I'll just enter it. Machine learning, but it have added some graphical features to it. So you need not to have Power BI tools with you. If you are having a data, raw data, right? You give to this tool, you can have it will be having the auto ML enabled model in it. So it will automatically going to clean your data as well. Then it will going to predict the things. With those prediction, it will going to create the beautiful graphs for you. So you need not to have any manual intervention involved here. Might be many other tools are there. I have used it, so I'm just showing it to you. See here. So you upload your data, whatever form it is, CSV, Excel, Google Sheet, API, whatever. It will automatically going to clean it. It will automatically going to analyze it using ML model, and it will going to show you the entire, GUI format graphs to us. If you come here again, many things are there, many things, right? See, this is how it happens. Very secure, right? It's not data will not going to go anywhere. So one of the things which we get from here. So if you see here, for business managers, data analysts, right? Anyone who is having or playing around with data, it's very useful for them. So multiple questions are also there in case you are checking out the thing. So let me log in and show it to you actually. A very good example, very simple example for a normal user to actually understand what machine learning is. So I log in. I log in it with my Gmail ID. Perfect. See here, this is something I prepared when I was creating a testing, examples for you. I created this, right? See this. Now what you can do is you can create your own project here. So just see if you are having access to this, everyone. I'll just ping it. I think there is a question also from Arvindan. OpenAI hide and seek games. Yes, games are always the example of reinforcement learning. Correct. Right. So just see if you have access to this. If not, then you can test this at home. If not here. Now, if you see here, I already added this CSV file here. Right. So if I click on it, or you can come here and create a new project also. Let me do it. See this. So you can paste a Google Sheet link. You can drag and drop things here, right? So let me put this file here, AI ecosystem. Let me change a name so that demo data, demo sales data, right? Enter. See this. It is uploading. Uploaded. See here. Processing. And what it will do is it will automatically going to create the charts for you. So it is showing 0 here. Let us wait. Now again, as soon as you put it, automatically ML models have started working on it. If it is a structured data, the supervised learning type will happen. Otherwise, it will going to be the unsupervised type. And see here, click to review. Click. It will ask us in case you want to add things or remove things or auto clean the data. See here, automatically. See this value, missing these values, blah, blah, blah. Come. So you can use your own cleaning options, customization option, or you can actually do auto clean, right? Let's say you doesn't belong to a machine learning experts, right? So you can just do auto clean as a layman. Now, when you talk about doing a lot of research, putting things, you can all choose whatever options you want to clean, but you are going to have everything here. This is all based upon the columns and rows we were having. See this. What we do is for this example, we will use auto clean and import. Now, if you see here, see this. Come. So it is processing things, and hence that's the reason these things are grayed out. Let's wait. See here, if I bring my cursor here, it is showing me you may create charts when the data is cleaned. So whatever was there, it is actually cleaning it. Now it is all done. See this. We have performed the following data cleaning tasks. Again, data preparation, corrected for inconsistent case pattern, detected two values, NA hyphen nil, blah, blah. See here, removed white spaces, right? 4 columns were having protective part so that we cannot have the data. So if you see here, all those things are automatically done. If you want to use your custom details, you can do it. Likewise, I shown you. Now, next is to create graph. Even it will actually suggest you what type of graphs you can create. So it will automatically going to create the things for us. Else, if you want yours, you can do it. So you can create your own charts. You want a chart, bar, or you want a gauge, completely depending upon you. So bar style, gauge style, whatever. And if you want this tool to take care of the things for you just for a testing purpose, as you are learning this tool, you can just say auto AI, click it, and it will automatically going to create the graphs for us. So we need not to have any Power BI or other complex tools to do such stuff for us. We have data, clean the data, and you can generate the graphs out of it. So let's see. It might take a couple of minutes, 1.5 minutes. Let's wait. See here, all done. Wonderful. See this. Understanding revenue contribution from by customer gender. See this. Now, even you come here, you can click on this tabular form. It will going to show you the details. A good one. See this. So you are having female, again something gender, right? It's again LGBT and all. And see here the males. See this. This is the place from where you will be able to understand. Okay, male gender have done more purchases than the female one for this particular product. Similarly, come down. I think it should generate something for state, for zip codes or for, let me see. So this is a good one. Comparing revenue generated by different payment methods, right? Come here, click on this. It will show you. Apple Pay, bank transfer, cash, credit cards, debit cards, PayPal, right? This will help you to actually strategize your outlets. If more things are coming from credit card, more credit card devices should be there. More coming from cash, more coming from some other places, and so on and so forth. So this will help you in streamlining such stuff. Likewise, see this one, this one. From which city the things have happened more? Click, see here. So from this zip code, this much revenue happened. This zip code, this much revenue happened. So these are states actually. So this is how you can use the power of machine learning. A good one, right, everyone? Simple and good. Just raise your hands if yes. Right? Now, even you can test it. What I'll do is, let me see if I can share this on chat. Let it get upload. I'll just give you this sheet, this sample data, right? I'll just share it. I just shared this data with you. Now, what you need to do, a very simple thing. Which one? The one we created last. Where is it gone? I think we created it with the name test, right? Yeah, test your knowledge. VI. Let me add. For AI practicals. So I'm just writing it here so that at the end of the sessions, I can share this with you. Or ML tests. I have shared the sample data set for sales of products. Use the same data set and test how machine learning works with already available ML softwares like Datasquirrel. I'll just copy this entire link for you. Oh, where is Datasquirrel? This one, right? Don't use your official IDs. Better to test this with your personal and least used IDs. I always write this because you should not give your primary email ID anywhere, right? Always remember this thing, and always create a new test ID and test whatever machine learning or deep learning or artificial intelligence softwares which are publicly available you want to test. Don't give your things. So if you're not having access, don't worry. I'll share it on email, everyone. Don't worry, right? So I'll just share it on email as well. We'll share the same email, right? And you can check it out then, right? So just use the same data set, right? Tools like this, right? and observe how ML will clean the data, or ML models will clean the data and helps us in predicting future needs, and with this software we are testing is also capable of generating graphs. Right, this one. So I'll just copy this and give it to you. Don't worry, Ganesh. Don't worry. I will share the same on email. I'll do it right away. Just give me 1 second. So this is the test you have to do. Let me check and share it with you all people right away. I'm going to give you 2 because the next one I'm going to use the other Excel sheet as well. Just give me 1 second. I'll share it right away with you all people. I think reply to all will help here to me if I'm not wrong. Reply to all. And 1, 2. Okay. They all is find attached sheet for ML demo 1. Try to use it and see. I shared it on email, everyone. I hope you will receive that email soon. And meanwhile, I'll share the second one also. This one, unfortunately, it allowed me just to put the first one. So I'll put the second one also. And the ML, this I have already shared, right? So I'll save it. And at the end, I will share the entire one with you. Now, useful example, just to understand how ML works, everyone. So your hands will help me to understand that, yes, it was useful for you. Perfect. Now comes the next one. So what we will do is we will understand another one. So now what we are going to do, we are going to understand another example, another useful example. And that useful example is from one of the services available. And that services, I'm again going to refer AWS, though such kind of services are available for Azure and GCP as well. But let me tell you what we are going to do. We are going to use another service called Amazon Forecast, ML service, because ML is for predicting things. So we are going to use forecast for it. Amazon Forecast service.
Yes,
Right?
so call me.
Can you please be on mute? I think someone is.
अरे कब हम पहुंच गए तो हम कोई बात नहीं.
Okay. So when you talk about Amazon Forecast, it's a fully
Yogesh, you are on mute.
someone muted me. Sorry, please don't do that. Am I audible now, everyone?
Yes, yes.
Perfect. So now Amazon Forecast. Amazon Forecast is a fully managed service by AWS. Why it is used? It is used to predict the future data. And this is why we use ML to predict the data, right? Based on historical trends, right? Whatever data we give, it actually does the thing for us, right? So you have it built with auto ML, means it will be having its own ML algorithms which are built in. Even you can provide your own models as well in case you want, right? Or customize the variables. It support the missing values. If there are missing values in your data set, automatically going to take care of the things. So it will actually help us in many things. And how it works? Very simple way. Very simple way, right? Number one, there are only 3 steps. We need to now that takes time. It's not super quick. It takes time basis on the data set we have. Then we are going to train the model. Then we are going to predict the things and then have the forecast generation. It takes time. But how it happens? 3 simple steps. Step number one, we are going to import the data set. Right? We need to have the data, import the data set. After that, what we do is we do a training. We actually set something called predictors. Those are called training predictors. So we give this data and we train our model. That's called training predictors here. Training predictors. This is the second step. It means you are building your model. Simple. And then finally, what you do a forecast generation. So it's forecast generation. Everything will be live on your AWS console. And this is forecast generation. And then you learn from it or you check the things from it and do whatever you wanted to do. Right? Many use cases. Retail demand planning, supply chain, resource planning, operational planning, wherever you are having future predictions, wherever you want to plan things, you can use Amazon Forecast machine learning service. And this is primarily why we use it as well. Now, what I'm going to do is, let me show you a capstone project. Now that project, if I do a live, will going to take approximately 4 to 5 hours. But what I did, I pre-trained the model so that I can demonstrate the things to you. Now, what we need to do? Simple project. So we are going to have Amazon. We are going to put the data here. Now in Amazon, where we are going to put the data? S3. So you create a bucket. You put your data set or your data. And then we will going to use forecast. Again, when you do it for the first time, you need to create the IAM so that forecast can interact with S3 and take the data and so on and so forth. Now what we do is we will going to use Amazon Forecast here. This is our service. We are going to put data here. We are going to take this data and feed it in our forecast. And then what we are going to do is we are going to do a training. We are going to train our model. Right? So we will train our model on this data to predict things. So we are just going to do that. Once training is done, right, it will going to provide us, let me do like this. It will going to provide us the results. Those results are called forecast. Predictions. Simple. In simple layman language, you can think of it as predictions. Right? You will see everything here. And the good part is how people does that, right? They don't want it to be here. You can take it and you can upload it back to your bucket also so that you can refer it and you can give access to this bucket to your programmers, to your data analysts, and you can do the things. So data analysts and others can use this data, right? Check it and come to a conclusion or whatever. This is how most of the organizations, if they are using forecast, this is how they leverage it. So they put things in the centralized storage. They train their model on that data. This is a time consuming. Let me let you know something. This is a time consuming. Basis on whatever amount of data you have, this will take time. Even for a simple data, it might take 3 to 4 hours, because this is the heart of the entire ML ecosystem training. So it will going to train. This will take time. Forecast generally take minutes, but again, it can be on hours. For simple data, right, it might take 30 minutes, 25 minutes. For complex and huge data, it might take more time. So on and all, it will going to take 4 hours approximately, or 4 to 5 hours approximately for simple data. And it might take more than 10 hours, 15 hours, 24 hours if you are having a complex data and you are training it. Right? So this time completely depends upon the data set. Perfect. Now let us come back and see this in action. And this is what I am going to use: electricity usage. I haven't taken a data randomly from anywhere. Rather, what I did, I took this sheet from Amazon reference only. So if I open it, let me show you. Okay, perfect. See this. So we are having data from 1st January 2014, and then there are the units consumed, right? And then you will see the client names. So this is electricity data usage. So this is for the year 2014, and we can predict the things for 2015 because I trained that model to predict the things for 48 hours, right? So I'll show you. So this sheet, I will give it to you. Come back. Let us close every other thing so that we should not be confused. Lambda function, IAM, close, dashboard lambda thing is there. Let us close, come here. So we'll again come back to the services, right? Under services, go to machine learning. Under machine learning, you will be able to see forecast. See this. Amazon Forecast is a fully managed service for accurate time series forecasting. So click. Right, see here. When you are doing it for the first, again, it comes under free tier as well. So you can use it. So whatever example I am showing you, you can use it. It will be completely free for you. See here, view dataset groups. In your case, it will show you to create a dataset. In my case, it is showing me view dataset because I have created this dataset for you. Reason being because it takes 4 to 5 hours to build it, to train it. So I'll create on view dataset groups. See here, this is the dataset. I created this, and this is nothing. If I click here, see here, importing the data. What I did, right? So we'll come back here. First step. Let me take it back. See this bucket. This one. So we need to feed the data. So what I did, I have taken the data from here. So this is all defined here. If you view, you will see the things. See here. Come down, 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 down. Right? This is all. See this. Next bucket, forecast electricity uses data.csv file. And I created a user as well so that it can have access to S3. So if you see here, this is all created. Right? Let's go back. So this is how you need to import the data. You can even import more data in case you want. Then comes the next thing. This one, train a predictor. Now this is you are training your model. Train a predictor, a custom model with underlying infrastructure for ML trains to dataset. So this is what we are going to train. This is a place. This is something which will going to take time. It will take 4 hours, 5 hours, basis on whatever data set and how complex that data set is, the time will be directly proportional to it. See this, if I click on train predictor, it will take time. So I will not click it here, but I will show you what I have already done. So in your case, when you are going to do it for the first time, you need to train it. So if I click on the view predictor, see here, I did it. And I actually did it, I think yesterday only. Not yesterday, day before yesterday. If you see here, I just built it for you. See this. Next, if I go back, again, you just click on this, it will take you to the dashboard. Automatically, this dashboard will come. Now, if you see here, generate a forecast. Model is trained, then you need to generate a forecast. When you generate a forecast, it will going to take 30-40 minutes and it will do it. Once it is done, then you can actually do a prediction. Example, query forecast. I wanted to check the things. Come here. I wanted to use this forecast which I have created. Now I have created it for 48 hours, means 2 days, which will be MMDD. Okay, so I'll take it from here. Unfortunately, I need to 2015. Let me do it. Yeah. So if you, I'll take this. If I give more, let me show you actually. 015. Let me give 7th January. And if I click on get forecast, it should show me an error. See this. Okay. It is saying required filter is missing. It should not show this error. Add required keys and values. It should not show this. Let me do it once again. Or I need to generate it. Demo forecast, it is there. 2015 01 01 2015 01, and let's say I want 10th this get forecast. No, it should not show me this.
The data is 2014, right?
Yes. Data is for 2014, correct? And I trained it for 2 days, means 48 hours. Okay, let us do one thing. If you see here, it is already done. Let us create a forecast. Now, if you create a forecast, it will ask you, let's say demo forecast, let's say new demo forecast, right? Predictor, we already created this predictor. Come down, all items, everything else. We'll keep everything as it is and we will start. Now, what will happen is it will take time. See this, create pending. Now, this is this part, this one, this part. It is creating a forecast for us now. Right? I specifically gave 48 hours, means I just want a prediction for next 48 hours, not for 1 year. Because if I'll do that, it will take huge time. So if you see here, create pending. So if I refresh it, unfortunately above there is no refresh button. So I need to do it from here. See here, estimate is 36 minutes. So after 36 minutes, it will going to show us the thing. But strange, it is not showing things here. We already trained it and I already enabled it. It is active forecast. Let us try it once again till the time it is building. Unfortunately, I will not be able to show you because if you see here, it removed the old one. So it is just showing me forecast generation in progress. So it means this is the improvement which can happen in AWS, wherein it can show us the old forecasts as well. But because I am creating it newly for the same time period, and hence that's the reason it is not showing me. So after 36 minutes or whatever time it is showing us, you will be able to see the things will be there. Showing active, but not displaying it there. Strange. right? So after 35 minutes, it will actually going to show us the forecast. Then with the dataset example, there is client 119. For client 119, what will be the prediction for electricity usage for next 2 days? So it will predict and it will tell us, right? This is how the prediction ecosystem works in Amazon forecast. We'll wait, let us see if it comes, then we will check out the things, right? But this is something you can try it out, right? Data I will give, so you can try it out. I'll write it here as a homework in case you want to do. Or ML AWS forecast test. I will provide the dummy data which can be used to train your model. Then use Amazon forecast and try to train your model. And once done, query the forecast to see the results. Again, one note, don't train the model for more than 48 hours prediction. As it may take huge time. This is just for your reference for testing it. In real one, we need to take more data because that is how it will going to help us, right? So this is something I'll just copy and I'll paste the chat. Yeah, Yuvraj, I could have selected a file, but again, what I did by mistake, I started creating a new generation. So yes, there would have been a good option to select the right file as well. But I don't know why it is taking a wrong file name or ID because I have already given a single file. Maybe something I missed. Perfect. So this is how the entire ecosystem of machine learning actually works. This was the data we were using. And you have closely seen there are three parameters to it. So one is the date, one is the units or consumptions, and the other one is the client, means the end users. Now we were getting one prompt, one key to be added. And that key was, now we want to see the prediction, but against which client? So that's the reason it was asking us the client ID. So the model was well trained. I tested it once this session get over. Once that session got over yesterday, so everything was working fine. So let us check it out before we get started with the other stuff. So let me log in. I'm logging as a root. It's not a best practice though. And let us go to our services, machine learning, and we were having forecast. And if you come down, we have our dataset groups, and here we were. So we have given the dataset, we have trained our model, and now we want to check the forecast. What we need to do? Query, right? See here, the new demo forecast we created yesterday, the old one was already there. So let's use our new one. Again, as we trained this model for 2 days, so I'm going to give 2015 because the data was for 2014. We are having a month, January, and we are having a date. Here again. Okay. Now, if you see this item ID, we need to put this client ID here against which we want the prediction to be displayed to us. Let's say we take client 26. So come back. But I'll show you one thing more. So if I give here, let's say 10th January, and I try to get the forecast, it should show us the error like this. See here, the date must not be before 3rd of January 2015. Why is it coming? Because during the training phase, during our model building phase, what I said, I just want the data to be predicted for 2 days. So if I try to get the answer for more than 2 days, we are going to get errors like this. So now we will replace it to 03. And then we will say get forecast. See here, it started processing. And if you come down, see here, we are having a forecast. Right now, if you see this P10, P50, P90, these are you can think of the closest predictions. Now, if you go and check this P10, P50, P90 in Amazon forecast. So if you see here, predictor accuracy. Now, this is something which is called quantiles in AWS. So if you click here, it will actually going to give you the entire details. So it will give you that how many people will fall under this category, how many people will fall under this category. So they have done a quantile analysis with this. So if you see here from 0.01 to 0.99. So if you see, these are the three which it takes by default. The true value is expected to be lower than the predicted value. The true value is expected to be lower than the predicted value 50% of the times, right? So this is also known as maiden forecast. So it will give you P10, P50 and P90 by default. If you want to customize it, you are always having the flexibility to customize such things. So I'll just close it. You can explore it. It's a good one. So see here. This is how it will going to give us the predictions. Now, next. Let me go back and we will come back to the last part of it, which is DL. Now, when we talk about machine learning, again, AI ecosystem. So AI ecosystem, as you know, it's very vast, right? Very vast, in fact. So what happens with it is, let me come in a simple mode here. Welcome. Yeah. Let us understand one thing first. So what we did, we understood AI. As I told you, AI is the entire world. Inside that world, you have another world, which is country actually. So you have a country. That country is actually ML. So you can think of AI as the entire world. And you can think of ML as a country. So you can say ML is a subset of AI. Simple layman language. So ML is a subset of AI. Next, when you talk about ML, we can do magical things. Yes, definitely we can do magical things. But when you talk about ML is having certain capabilities. Beyond that, it will not going to help you. And then you need to put a lot of manual efforts to get that worked. And that is where, the things will become more complex and time consuming. So when you talk about ML is very well suited for 70% of the cases for us. But it lacks when you have a complex data set, right? Complex data set. As data set is now, as you know, the data is exponentially growing. So it is becoming more complicated. Just doing a filtration at one level will not going to help us because it might lead to inaccurate results. And it might lead to manual interventions by doing re-engineering and putting a lot of manual efforts to get that model worked. Too time consuming as well. So as data is getting more and more complex, the machine learning algorithms are getting little fade out when it comes to complex predictions. This is one thing. Second thing is the complex data. Now to represent complex data in a complex way is again one of the challenge. So the representation of a complex data, right, is again becoming very challenging. Right now, because of these two pointers, complex data set and complex representation, right, a new thing came into a picture to mitigate that. And that mitigation is being done using another emerging field in AI, which is called DL. DL is also a machine learning, right? It's not something different. It's a machine learning only, but specifically done for complex data sets, right? So now this DL is a subset of machine learning. So you are having a world, you are having a country, and inside this country, you are having a state. So this state is a DL for specific ML subset of AI. So again, DL is a subset of ML and ML is a subset of AI, and AI is a holistic term which is used. Right now, when you talk about DL, right now, again, some of the examples which probably I can come off with, let's say a simple one. Let's say you are having different smileys with you. Smiling smiley, a sad smiley, I think very happy smiley, and so on and so forth, right? With no mood smiley and so on and so forth. Now, when this data is getting more and more and more and more, you want the computers to identify the moods automatically and basis on that provide us the outputs. With machine learning, it is not possible, but with deep learning, it is possible, right? Because deep learning will going to have the predictions for multiple things in hand. So when someone is smiling, their mouth goes up and their eyes might crinkle and so on and so forth. So you train your model in deep learning like that. And then it will going to find out everything for you. And it will put it and it will share the details for you. Likewise, if the data set is getting more and more complex, now this is just a simple example, but when the data set is getting more and more complex, this is where the deep learning will actually going to come and save us. So as I said, subset of machine learning that involves another thing. When you talk about DL, you will always hear another term called ANN. Or sometimes you will just hear NN. NN is most used, but it is ANN, artificial neural networks. So deep learning is actually completely relying upon something called artificial neural networks. The network which is completely built like human brain. It is completely inspired from human brain. So it makes the decisions, intelligent decisions, rather, I would say, without explicitly programmed. Right? So we are teaching computers from experience. So we are teaching them to learn from experience. Right? So deep learning is completely depending upon your artificial neural networks. Now, what is artificial neural network? So artificial neural network is nothing. It's artificial neural network is like multiple layers, or let me simplify this. Let me simplify this so that you can understand probably in a better way. Let me take a typical example from Unix or Linux. Let's say I'm having one folder and that folder is having 1000 files and directories. And I have to find out something which starts from Y and which ends with SH. Let's say all files related to it. So first of all, what I'm going to do here, I'm going to have ls-lrt or ls-l. Then I'm going to grep and I will say -i, anything starting from small y listed for me. Let's say it listed here 100 files for me, which are starting from y. First filtration done, right? Second filtration. Now I want from these 100 files, anything which is ending with ESH, right? Just give that to me. So what it will do is it will again do a filtration and let's say give me 10 files. And then I'm having this clean data. Wow. And then this clean data I can use for whatever work or whatever predictions I want to use. Similarly, deep learning works. Now, what will happen in deep learning? This is called layer. You have a data, this, and data will go to multiple layers and multiple alterations, not alteration, alteration is a bad word. The cleaning of the data will happen. Layer one, then layer one will be having the complex data is little less complex, and then we will going to do it, put it in the another layer. It will become less more complex. Then we will put it in another layer and it will become our clean data. This clean data, this complex data has become a clean data. Now this clean data will go and going to do the vendors for us for predictions. This is where it works. Now, how it works in DL, we say it as neural network. DL is nothing. DL is neural network, right? A model is termed to be a deep learning model if it is having ANN's layer more than 3 associated with it. A good neural net, a good deep learning model will be having at least 3 layers. So what will happen here actually? You give the inputs. There will be input. Let's say this is a data set. So you give this as an input. Now this data will going to go through some hidden layers. This is called input layer. And then in artificial neural network, there will be multiple hidden layers, which will going to do a magic for this particular complex data. So data came, right? So data will go here, 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 and here. And then these layers, they all are connected to each other. All are connected to each other. They are all connected to each other in both ways, reverse direction and forward direction. Usually it is in a forward direction, like this layer will do the function, provide the details to this layer, and then this layer will validate the things and going to provide the outputs to us. This is how the human brains are evolved. If anything, you just you know, just touch your right finger. You will see your brain is actually calculating it. Okay, something is happening. Now you are touching your finger, but you are, you are having sensation in your brain also, right? How is it happening? Is it happening all because of the connected neural networks inside our body? Similarly, this DL will be having these internal connected layers. These are called hidden layers. Once the data is cleaned, all set, then it will actually going to give the output back to us. And this is called output layer. And we are going to have the clean data. It can be predictions, it can be whatever. This is how the ecosystem of neural network works. It's called ANN, artificial neural networks. So deep learning, right? So deep learning refers to the depth of layers in the neural network. So we always in a deep learning. Deep learning. There is a meaning to this deep. This deep means number of layers. How many layers are there in the neural network on which the model is trained? A good model, again, as per the generic, considerations, if any deep learning model is having more than 3 ANN layers, that algorithm is considered as a good one. right? So you will always see good DL models will always going to have at least 3 neural network layers. Let us come back, see here, see this. So we were here, challenges with ML, right? Deep learning, artificial neural networks or neural networks, ANNs or NNs. Then if you see here, DL, and this is how the layering functions. Next is use cases. Now there are many use cases to it. Let me open it. Right? Many use cases. Now, object detection. Now, when you talk about self-driving cars, right? Driverless cars, you need to have image scanning, you need to have object detections, and you need to have many other things. So object detection and self-learning or driverless cars, these are the best examples of deep learning because you don't know what will going to happen. This data needs to be there, right? Needs to be there. And then you have NLPs, right? So you are speaking in one language or you are speaking something is automatically getting written. You're speaking in one language, it is getting translated to another language. So all this ecosystem is translations. NLP is a best example of deep learning. So when you talk about NLPs, natural language processing. So when you talk about NLPs are the best examples of deep learning. All NLP models are deep learning models. Sentiments. Now, when you talk about any human, the most difficult thing is to do a sentimental analysis. It need huge data and it need huge filtrations. So deep learning is actually working on it. Again, many things needs to be done, right? They are not perfect at present point in time, but things are going pretty fast in this direction. Medical image analysis, very, very good one. Right? When you talk about the drug discoveries, when you talk about releasing the drugs as fast as possible, right, in minimum possible time, that is all being happened using deep learning only. Otherwise, it is very difficult to discover and release a drug within a month time or 2 month time or 3 month time. And when we talk about a real example, the corona vaccine is one of the realest examples of that. The next one is the personalized medicine. As I told you, understand the entire current situation of a person, understand the genetic details in the past, put it in the ecosystem of deep learning and predict what might happen wrong in future with this person, and then do the medication likewise. Nowadays, again, earlier the recommendation systems were based on machine learnings, but the intelligent AI-based recommendation systems today, they are partially using ML, but heavily relying upon the DL as well. Right? So this is how the ecosystem of DL works. So NLP is one of the best examples of that. So if you want to test out the things in practical, go with the NLP services. Right? Example, I think AWS Comprehend is one of the service. If I am not wrong. Machine learning. Yeah, analyze unstructured test. This is also one of the deep learning, deep learning services of AWS. Even you have SageMaker, which is a machine learning. I think Ashraf have shared that. So I'll give you a couple of YouTube links, which probably I would recommend you to go through. So just to, understand, one is the SageMaker. I'll copy this link. So you will be able to see the practicals of SageMaker here. So if you want to check how SageMaker works, so this is one of the best examples. So you click here, you will see everything. So this is developed by us. So just for a quick demo, right? If you come here, you will see all things here. How to do, what to do, all explanation is given here. So this is one of the machine learning. It's a Jupyter notebook and all. So you will be able to see all such. So you can check it out. It will be useful for you. And there is another one, which probably I would suggest you to go through it. This one I already showed you, right? And this SageMaker, the theoretical part. If you want to understand the concept, you can just go through this one as well. The recognition, in case if you want to check out, you can. And in case you want to understand, what machine learning is, just for the people who are pretty new to it. So these couple of links will going to help you out, just to have a strong basics, right? And this is for recognition hands-on, which we already did. This one. Apart from that, I think that is all okay. Yeah, I think those were the one which probably will be useful for you. Yeah. Perfect. So with this, we come to an end for today's session. And what primarily we understood, we started with absolute basics for AI. Then we get little deep into it and we understood and did some hands-on on the AI services. And then we took ourselves little deep into technology, but I tried my level best to keep it so that everyone can understand it. So we understood ML, machine learning, and then finally we understood something called DL. Right? And all examples were shown. So don't worry, the recording is also happening. So we will share the same recording with you all people in a day or two, right? And next, once this is done, tomorrow what we are going to do is we will understand where DL is lagging and how GenAI came into a picture. We'll start again from absolute basics. You need not to have any prior knowledge of anything, but we will start with a problem statement. Why generative AI? When DL was there, predictions is there, data is there, why GenAI? So this is going to be our first question with which we are going to get started with the things. Then we will understand what all things have been changed here. And then we will come to GenAI use cases. And tomorrow, maybe if time permits, I'm going to show you 8 to 10 use cases. And we are going to actually build one of our chatbots also. Very simple. We are going to use something called Bedrock, AWS Amazon Bedrock service as well. And I'll show you how sometimes things are good and sometimes things are bad. How the relevant answers are coming or relevant answers are not coming, and so on and so forth. And then finally, we will discuss about the risks and ethical considerations for artificial intelligence. Perfect. So I hope this was useful for everyone, and I'm hopeful to see you tomorrow. I know it's a lunchtime, so you all have to rush now. So I will not take much of your time. So thank you so much, everyone. I'll see you tomorrow.